Night has fallen, and you find yourself beneath a vast celestial canopy of stars. The world around you is quiet and still. A gentle breeze brushes your skin, and the scent of earth and grass comforts you as you lie back and gaze upward. Above you, the sky stretches like an endless dome of deepest blue, fading slowly to black as the last traces of twilight dissolve. One by one, the stars are emerging. First a few pale glimmers, then dozens, then hundreds, until the night is brimming with their distant fire. Out here, far from any city lights, the heavens reveal themselves in breathtaking clarity. Each star shines with a steady, gentle light. Some are bold and bright. Others are faint and delicate, like tiny pinpricks of silver dust. They seem to twinkle as if whispering ancient secrets across the light years. Overhead, the Milky Way arcs from horizon to horizon, a soft, luminous band of countless stars woven together like a celestial river. It glows as a hazy, silvery cloud, reminding you that our sun is just one among these myriad lights. You take a slow, deep breath in, filling your lungs with the cool night air, and feel a deep calm washing over you as you gently exhale. With that breath out, you let go of any remaining tension, watching it drift away like a small cloud into the dark. The vastness of the cosmos above makes everyday worries feel small and distant. Here, under this glittering blanket of sky, you feel safe, peaceful, and almost weightless, as if the Earth's gentle gravity is the only thing tethering you from floating up into the starlight. In the distance, you can hear the subtle sounds of the night. A distant owl, the chirp of crickets, a soothing chorus that only accentuates the serenity of this moment. As your eyes adjust, more and more stars appear, too many to count. They sprinkle the sky in every direction, an infinite tapestry of light and darkness. High above, you notice a faint shooting star, silently streaking across the darkness, vanishing in an instant, but leaving behind a sense of wonder. Was it a tiny grain of cosmic dust, burning up as it entered the atmosphere? The thought that you have just witnessed a bit of celestial material reminds you that the earth, your body, and everything around you are part of this great cosmic arena. You feel a connection to the stars, as if they are old friends watching over you. People have been gazing at this same sky for thousands of years, telling stories and dreaming about the lights above. Perhaps you recall a few constellations overhead. Maybe you spot Orion with his belt of 3 stars, or the graceful curve of the Big Dipper pointing to the North Star. These patterns are comforting in their familiarity. They have guided travellers and inspired myths. Under this sky, you sense the presence of those ancient stories, of gods and heroes immortalized in the constellations, yet all is silent and calm. Directly above, the night sky is a deep velvet black, dotted with brilliant jewels of starlight. Toward the horizon, the blackness softens to a dusky blue, where the last memory of daylight lingers. On that horizon, if you look closely, you can see a particularly bright point of light that doesn't twinkle like the stars. It shines with a steady glow. Perhaps that's a planet, one of our neighbouring worlds reflecting the sun's light. You might not be sure which planet it is, but its warm, constant gleam stands out among the twinkling stars, a reminder that even in the night, The sun's family of planets are all around us, sharing the sky. Time seems to slow under this stellar canopy. Every breath you take is unhurried and full. With each exhale, you sink a little deeper into relaxation, as if melting into the earth below you. The heavens above spark your imagination, gently beckoning your mind to wander among them. You imagine drifting upward, weightless, toward those glittering lights. There's no rush, no destination at this moment, just the sheer joy of being present in the middle of this infinite calm. Far above, an almost invisible haze of light marks the plane of our galaxy. That subtle band, the Milky Way, is made of uncountable stars far beyond our solar system. Yet your eyes also pick out some distinct stars closer to home, like that soft red glimmer, perhaps Mars, or a golden one that might be Saturn. They all join the nightly display, each one a distant sun or a neighbouring planet, all part of the grand cosmic tapestry that surrounds us. In this peaceful darkness, a gentle curiosity awakens in you, a desire to explore these distant lights more deeply in your mind. The sky overhead is no longer just a flat curtain of lights, but a three-dimensional universe that stretches unfathomably far. Each star is at a different distance. Each point of light is a sun with its own story. Among them, our own solar system is just a tiny neighborhood, yet filled with wonders that humans have only begun to understand. You close your eyes for a moment and let the serenity of the night wash over you. The cool breeze, the soft chorus of night creatures, the solid ground supporting you, all anchor you in comfort. You feel the earth's subtle rotation as a comforting lull, carrying you eastward beneath the stars. When you open your eyes again, you notice the tiniest crescent of a moon peeking above the horizon, or perhaps it's a moonless night, and the sky is letting the stars take center stage. Either way, the darkness feels kind and nurturing, not empty at all, but full of possibility. Above, the constellations slowly drift as the earth turns. Yet to you, lying here, it's as if the cosmos is a giant dome revolving gently around you. You feel at the center of something eternal and vast. There is a slight sense of mystery in the air, the knowledge that beyond that sea of stars are even more distant galaxies, and within our own solar system, unseen at this hour, are planets, moons, and the sun itself, each with their own beauty. Contemplating such immensity might make one feel small, yet instead you feel intimately connected to it all. After all, the very atoms in your body were born in stars long ago. In a literal sense, you are made of the same cosmic material as the glittering heavens above. Far from home, you realize that you carry a piece of home with you wherever you go in the universe. You belong among these stars, a child of the cosmos, and that thought is deeply comforting. Under this celestial canopy, you allow your mind to begin a journey. Perhaps you feel as though you are rising now, leaving the cool grass and the soft hum of Earth's night behind. Not with any jolt or fear, but with a peaceful grace, as if the universe itself has taken you by the hand. The stars around you seem to brighten as you float upward into the night sky. Below, the landscape grows smaller and the horizon gently curves. The earth, your home, is a vast and beautiful sphere that you are slowly departing, at least in spirit, for a little while. High above your resting body, you drift weightless and free, a silent observer among the stars. The earth is below you now, and ahead the infinite cosmos. The quiet is profound, a comforting silence, broken only by the steady rhythm of your breath, and maybe the imagined distant hum of the cosmos. You feel a sense of anticipation, a childlike wonder about what lies ahead in this journey through space. Tonight, you will voyage beyond that comfortable patch of grass, beyond even Earth's atmosphere, to visit the wonders of our solar system. Each destination will come to life in your mind's eye as you float gently from one world to the next. You remain completely relaxed, protected by an aura of calm as you travel farther from home, yet somehow always connected to the warm, safe feeling you have right now. The stars will be your guides, and the night will carry you. Let curiosity and tranquility guide you upward and onward. You are drifting through the darkness of space now, leaving behind the twinkling blanket of stars as seen from Earth's surface and becoming part of the cosmos itself. In this boundless space, you are at once tiny and immensely important, a traveller and a part of the universe itself. The velvet darkness around you is dotted with lights near and far. Ahead, you sense a gentle radiance growing, a warm glow beckoning you forward. It is as if the night itself is guiding you to the first and greatest of our solar system's wonders, the sun, the luminous heart of our cosmic neighborhood. You glide through the silent void, drawn toward a gentle brilliance ahead. Gradually, the source of that radiance reveals itself. The sun, our home star. In the emptiness of space, it hangs before you as a great glowing sphere, alive with light. This is the heart of our solar system, the warm beacon that every planet and moon circles in its graceful cosmic dance. Even from a safe distance, the sun's presence is overwhelming and magnificent. It shines with a pure white gold light, so intense that it would normally blind your eyes. But here in this dreamlike voyage, you are protected and can gaze upon it without harm. Its edges flicker and shimmer, a constant gentle pulsing as the star's energy pours into space. A faint halo of pearly light surrounds it, the sun's corona, usually hidden from view on Earth, except during an eclipse, now visible as a delicate crown, extending millions of miles outward. This halo sways and ripples slowly, like a silken veil dancing in a breeze, glowing with soft iridescence against the darkness. As you draw a little nearer, you notice the sun's surface is not solid at all, but a roiling ocean of incandescent gas. Patterns form and dissolve on that bright sphere. There are slightly darker patches here and there, sunspots, temporary islands of cooler gas on the sun's face, drifting slowly across its surface. Around these spots and along the sun's glowing limb, you occasionally perceive graceful arcs of light, loops of glowing solar material arcing high above the surface before falling back. They move in slow motion at this distance, appearing as serene, curved flames suspended in space. Though they are huge, many times larger than the entire Earth, they seem delicate from here, mere filaments tracing the sun's magnetic embrace. The sun is utterly silent in the vacuum of space. You can't hear the immense furnace of nuclear reactions at its core, but you can sense a deep, soothing hum resonating in your imagination, a kind of cosmic heartbeat. It's as if the sun itself has a pulse, a slow, reassuring throb of energy that echoes faintly in your mind. You feel that sound rather than hear it, a comforting vibration that reminds you this brilliant star is alive in its own way, steadily burning for billions of years and still only in its middle age. By human reckoning, it is incredibly ancient, and yet it will continue to shine for billions of years more. Countless generations into the future will wake to its dawn as reliably as we do now. For a moment, you recall how this sunlight feels on your skin back on Earth. A memory of a bright morning where golden rays warmed your face and lit up the world. All that warmth and life originates here, in this shining star before you. Every beam of sunlight that ever kissed a leaf or stirred a breeze began as a particle of light in the sun's core, created when tiny atoms fused in its unimaginable heat and pressure. Just 8 minutes is all it takes for that newborn light to travel across the void to reach Earth, delivering the sun's gentle embrace across nearly 100 million miles. How miraculous that something so intense can feel so gentle by the time it graces an early summer morning or a cozy winter afternoon. Floating here in space, you watch the sun's constant illumination spilling outward in every direction. Sunlight streams far past you, a river of photons that will reach the planets, warm them, and then continue on to fade into the vastness. You imagine Mercury, so close to the sun, bathed in fierce light. You think of Venus and Earth, each receiving the right amount of this energy to light their skies. You even consider how the farthest planets, tiny pinpoints from here, still catch a faint glimmer of this star's gift. The sun's glow paints the surrounding space in a gentle twilight. If you hold out your hand, the side facing the sun is bathed in brilliant light, while the other side remains in deep shadow. There is no atmosphere here to scatter the light into sky blue. Space remains black even as sunlight falls upon you. It's a peaceful contrast. The brilliant life-giving star and the infinite night of space existing together seamlessly. Looking at the sun, you are filled with a sense of reverence and comfort. This star has carried the solar system through eons of time. It gathered the planets from a cloud of dust long ago and has guided them in orbit ever since. Its gravity holds you and everything else in this system gently in place. Its light and warmth have allowed life to flourish on at least one world. You feel a kinship with the sun, as if its steady light is watching over you like a loving parent watches over a child. In its glow, there is a nurturing quality, a cosmic reassurance that each new day on Earth will dawn under its rays. As you continue to drift, you let the sun's radiance wash over you, not as burning heat, but as a balmy, soothing warmth. It feels as if you are being softly embraced by sunshine itself, a tender solar embrace that reaches across the emptiness to hold you. You recall lazy afternoons lying in sunlight, the way that warmth can lull you into drowsiness. Here, in the cradle of space, that sensation is magnified into something almost spiritual. The light seems to seep into you, filling you with tranquility and quiet joy. You take a moment to look around at the space surrounding the sun. Tiny motes of dust and gas catch the sunlight and glint as they drift by. Perhaps you even see a comet in the far distance, a pale tail of vapor lit by the sun as it races along its long orbit. The sun illuminates all it touches, revealing the beauty of even the smallest particles moving through the void. Somewhere far beyond, our spacecraft and satellites bask in this light, silent guardians orbiting Earth or travelling to other planets, always dependent on the sun's energy. Even farther out, two small Voyagers, Voyager 1 and 2, have gone beyond the planets, but they too once slingshotted around this sun to gain speed, and even now they still feel the faint pull of the sun's gravity and the memory of its light as they venture into interstellar space. This star's reach is long, both in gravity and in spirit. The sun is more than a source of light. It's also the gentle tug that keeps the planets from wandering off into the galaxy. As you drift near it, you sense that gravitational presence like a soft call drawing you inward. But your journey must continue, carrying you outward to visit the worlds that circle this star. You have basked long enough in the sunlight. Now it's time to explore those planets that know this light in their own unique ways. Before moving on, you take one last lingering look at our sun, committing to memory the sight of its radiant sphere suspended in the darkness. The brilliant corona flickers with ethereal light, and a particularly graceful prominence arcs out like a fountain of fire, and then gently falls back, almost like a wave goodbye. Within your mind, you send the sun gratitude for the daylight it gives, for the life it supports, for the simple beauty of its presence. Slowly, you begin to drift away from the sun now, letting its golden light fall behind you. In the distance, its glare diminishes slightly, and the star becomes a bit more defined against the black. Surrounding you, the darkness of space grows deeper again, filled with the pinpoints of far-off stars. But up ahead, closer than those distant stars, a small round world is coming into view. This is Mercury, the first planet from the sun, a tiny rocky sphere, scorched by the sun's embrace, and locked in an eternal dance with our star. You feel an excited calm as Mercury approaches, knowing that this lonely little world holds subtle wonders of its own. Guided by the sun's light, you move closer, ready to greet the innermost planet. Mercury's barren surface comes into focus as you glide closer. It is a tiny world, the smallest planet in our solar system, looking almost like Earth's moon at first glance. The ground below is a patchwork of craters upon craters, countless circular scars from ancient collisions with meteors. In the stark sunlight, you see these craters casting long, sharp shadows across the greyish rocky terrain. There are also smoother plains of ancient lava and fields of dust and rubble. The horizon is jagged with the rims of craters and low hills. Everything appears still, silent, and frozen in time. As you hover gently above Mercury's surface, you notice how stark the environment is. There is no air here, no wind to stir the fine dust or paint the sky blue. The sky overhead is pure black, even though the sun's brilliant disk dominates it. Without an atmosphere to scatter light, the sun appears as a blinding white orb in a pitch-black sky. The stars would be visible even at noon here, if you could block out the sun's intense glare. It's a strange and beautiful contrast, the brightest daylight and the darkest sky coexisting at once. On Mercury's day side, the sunlight is fierce. This little planet orbits so close to the sun that the heat is extreme, The rocky ground below you has been baked for ages by the sun's rays. In places, it may be hot enough to melt lead by noontime. Rocks and dust soak up the sunlight until they are scorching to the touch. But you, floating just above the surface in your protective cocoon of imagination, feel only a gentle warmth, like a sunny afternoon back on Earth. You are safe and comfortable, observing without any harm as Mercury endures the sun's powerful embrace. Looking toward the horizon, you sense Mercury's smallness. The curvature of this world is more pronounced than on Earth. If you were standing on Mercury, you might almost feel the closeness of the horizon, as if you could nearly reach out and touch the edge of the sky. Because Mercury is so small, only about a third the size of Earth, the horizon falls away quickly. It makes the landscape feel oddly intimate, despite being an entire world. Time moves differently here. Mercury rotates very slowly, so slowly that a single day-night cycle on Mercury lasts much longer than its year. In fact, the planet spins only 3 times on its axis for every 2 orbits around the Sun, from one sunrise to the next on Mercury. About 6 Earth months pass. Imagine the Sun rising and then climbing painfully slowly in the sky, baking the surface day after day, week after week, before eventually sinking down again into a months-long night. It's as if time has stretched out, giving Mercury long, lingering days of light and equally long nights of darkness. You drift across the terminator, the dividing line between day and night on Mercury. On one side beneath you, the terrain is illuminated in stark clarity by the high sun. On the other side, it disappears into darkness and deep cold. Mercury's night side is frigid, with temperatures plunging hundreds of degrees below freezing once the sun sets. Without sunlight, all the heat radiates away into space, leaving the rocks as cold as interplanetary night. Yet even in these extremes of heat and cold, Mercury holds quiet secrets. Tucked into the permanent shadows of some deep polar craters, where sunlight never reaches, lie deposits of water ice, preserved for eons in the darkness. It's a gentle gleam of frost in the solar system's hottest realm, an unlikely sanctuary of ice on this closest planet to the sun. Perhaps in those long nights, Mercury seems to rest, its surface releasing the heat of the day and waiting patiently for the dawn that will eventually come. Now picture yourself witnessing a sunrise on Mercury. After the endless night, the first sliver of the sun's blaze appears over a distant crater rim. There is no rosy dawn here, no atmosphere to paint the sky, so the sun emerges as a sudden, brilliant crescent of white fire against the blackness. Slowly, ever so slowly, that crescent grows. Minutes pass into hours as the sun lifts higher, its light spilling into craters and valleys that were in darkness moments before. Steep crater walls that lay in shadow begin to glow, their peaks catching the sunlight first, like beacons. Gradually, the entire landscape before you is illuminated in stark relief. The ground that was bitter cold starts to warm under the unwavering daylight. Rocks glint, and the frost that collected during the frigid night sublimates into space, vanishing like a phantom breath. It is a slow, grand dawn, revealing Mercury's ancient surface anew. You are a silent observer to this spectacle, filled with quiet awe as night turns into a long, brilliant day. As the sunlight spreads across the ground, you observe cliffs that run for miles, cutting across craters and plains. Along the surface, you observe these great cliffs, jagged scarps that cut across crater walls and plains. These are wrinkles in Mercury's crust, formed as the planet's interior cooled and shrank over billions of years. They stand as silent testimony to Mercury's active past. But now, Mercury's interior has quieted. There are no active volcanoes or shifting tectonic plates here anymore. It is a world that has largely spent its energy, now locked in quiet, enduring stillness. The only changes come from the occasional meteorite that still pockmarks its surface, and the slow, relentless bombardment of solar radiation that ever so subtly alters the rocks. Floating just above Mercury's rocky plain, you notice one especially large crater, a massive circular basin with rippling rings of mountains inside it. This ancient impact site, among the largest in the solar system, hints at a violent event long ago. Now it lies quiet, its cliffs and central peaks casting long shadows at dawn. In the airless silence, you imagine what it would be like to stand there. Above you, the sun looms more than twice the size it appears from Earth. When it rises here, it floods the basin with blinding light, revealing every jagged rock and dusty slope. When it sets, darkness falls almost instantly, with no atmosphere to create a lingering twilight, just sudden night and the immediate appearance of a sky full of brilliant stars. Mercury lives up to its name as the swift messenger of the gods. You sense the planet's speed as it orbits. Mercury races around the sun faster than any other planet, completing a full circle in just 88 Earth days. In your mind's eye, you picture Mercury zipping along its elliptical path, always rushing through dawn and dusk relative to the sun. This swiftness is why the Romans named the planet Mercury, after their fleet-footed messenger with winged sandals. Indeed, Mercury, the planet, moves like quicksilver around the sun. Despite being so close to the sun, Mercury can sometimes be seen from Earth during the fleeting moments of twilight. Perhaps you think of those times, just after sunset or before sunrise. Mercury appears as a small, bright dot low on the horizon, glimmering in the glow of dusk or dawn. It never strays far from the sun's vicinity in our sky, always either a herald of morning or an envoy of evening. In this way, Mercury is a true twilight messenger, revealing itself only in the dim transitions between day and night, as if delivering a secret message from the sun to the earth, before vanishing again into the sun's glare. As you marvel at this scorched little world, you feel a gentle admiration for Mercury. It's a survivor, scorched and pelted by the cosmos, yet steadfast in its orbit and faithful in its dance around the sun. It carries the marks of the solar system's youth on its ancient face, a history written in craters and cliffs. And through it all, Mercury remains elusive and shy to those who watch from Earth, peeking out only briefly as a bright spark in the twilight. Now, as Mercury begins to slip behind you, you turn your gaze outward, away from the sun, toward the next planet in line. There, shining ahead of you in the darkness of space, is a radiant beacon cloaked in thick clouds. This is Venus, the second planet from the sun. Her presence is unmistakable, a brilliant white gem against the starry background, glowing steadily. You feel a subtle change in the quality of light, a softening of the sun's glare, as the glow reflecting off Venus's cloud tops reaches you. With calm anticipation, you drift toward this veiled goddess of the skies, ready to explore the mysteries she hides beneath her clouded veil. Venus grows larger as you draw near, a shining pearl set against the black velvet of space. Even from afar, the planet gleams brilliantly, by far the brightest of planets as seen from Earth's skies. Now you see why. Venus is completely swathed in thick clouds that reflect sunlight like a giant mirror. The entire globe is wrapped in an unbroken blanket of white golden haze, giving it the appearance of a perfect, featureless sphere of ivory. There are no surface markings visible, no breaks in the clouds, just a smooth, gently glowing disk. It's as if Venus wears a wedding veil of cloud, concealing whatever lies beneath. Drifting closer, you find yourself above those endless cloud tops. The sun's light is intense here, but much of it is thrown back into space by the clouds below, which is why Venus shines so vividly in our night sky. The upper atmosphere stretches beneath you like a vast, pale ocean of swirling vapour. You notice subtle hues in the cloud layer, faint butterscotch and pearly white tones, hints of sulphur and other elements within. Broad spiral patterns curl through the clouds, stirred by high-speed winds. Unlike calm Mercury, Venus's upper winds roar around the planet, circling it completely in just a few days. From up here, however, it all looks gentle and slow, the cloud deck stretching out like softly whipped cream, with vague patterns that drift and morph almost imperceptibly. The scene is peaceful from where you float, but you know it belies a more turbulent truth below. You imagine descending through that thick veil. As you slowly sink into the clouds, safely in this imaginative journey, the light around you becomes a golden glow. The sun above grows fainter, diffused by layer upon layer of cloud. For a time, it's like being inside a glowing fog, warm and otherworldly. Fine droplets of sulfuric acid swirl around, catching the dimming sunlight and refracting it into diffuse halos. There's a strange beauty to it, like being inside a golden storm cloud at sunset. Deeper and deeper you drift, and the air grows hot and heavy. You can't see it with your eyes, but you sense the pressure mounting, the atmosphere growing dense. Somewhere far below, hidden from sight, is the surface of Venus, a place no stargazer on Earth can see, forever secluded beneath the clouds. You know it's there, a rocky landscape of mountains, valleys, and vast volcanic plains. Perhaps it's somewhat like how Earth's surface might look in a fever dream, scorched deserts stretching under a perpetual overcast sky. If you could stand on Venus and survive the conditions, the sky around you would be a dim orange, the sun only a bright smear of light overhead. Daylight on the ground would feel like a perpetual murky twilight, glowing faintly through the dense air. Venus rotates so slowly and in the opposite direction of its orbit that a single day on Venus, sunrise to sunrise, lasts longer than its entire year. The sun, if it could be seen, would strangely rise in the west and set in the east. But even these concepts lose meaning on Venus's surface, where the sun's disk is completely hidden and the thick atmosphere spreads the light into an eternal simmering glow. Under that blanketing sky, the temperature is astonishingly high, the hottest of any planet, even hotter than Mercury at high noon, despite being farther from the sun. The dense carbon dioxide air and clouds act like a giant thermal blanket, trapping the sun's heat relentlessly. The surface rocks bake at temperatures that could melt lead, and the pressure is crushing, like being 900 meters under the ocean on Earth. Venus is truly a world of extremes, a great furnace sealed beneath a curtain of clouds. Yet in this harshness, there is something awe-inspiring. Venus, the veiled goddess, holds her secrets close. For billions of years, she has kept her face hidden from our eyes, forcing us to learn of her nature through indirect means. radar maps, and a few brave probes that survived only moments on her surface. You recall that Venus was named for the Roman goddess of love and beauty, and indeed, from afar, she is the most beautiful star in the sky, shining pure and steady each morning or evening. There is an irony and mystique in that. The planet named for the gentle goddess is in fact a wild, stormy realm beneath the veil. Perhaps it's a reminder that there is often more to a thing than meets the eye. Hovering above the cloud tops again, you let the harsh realities of the surface drift from your mind and focus on the tranquil beauty of what you see. The sunlight here paints broad, glowing highlights on the tops of the clouds. In the shadowed portion of Venus, the night side, the cloud tops are lit faintly by the ghostly silver glow of earthshine, or perhaps by flashes of distant lightning far below. A silent flicker illuminating the clouds from within for a brief moment. If you watch closely, you might catch one of these faint flashes, ripple through the cloud layers, then fade away, leaving the shrouded world below in darkness once more. The planet's night side is otherwise dark to your eyes, but you know that it's still unimaginably hot beneath those clouds, day or night, due to the thick air's grip on the heat. From Earth, Venus has always been a beacon. Perhaps you imagine how it looks right now to someone back on that quiet field where our journey began. If it's early evening, Venus might be low in the west, shining like an unblinking diamond in the twilight, the first star to appear after sunset. Or if it's early morning, Venus could be rising ahead of the sun, a lone bright herald of dawn. For this reason, ancient cultures often revered Venus. The Greeks called the evening star Hesperus and the morning star Phosphorus, not realizing at first that both were the same object. Venus was seen as a symbol of beauty and love across many civilizations. How wondrous that this light in our sky is actually a distant, cloud-covered planet, with such a fierce environment hidden beneath its lovely glow. You take one more moment to appreciate the lovely crescent shape that Venus would show if the sun were off to your side. Just like our moon, Venus goes through phases as seen from Earth. At times it appears as a full but smaller disk. At other times, like a slender crescent that is closer to us and even brighter. In your mind's eye, you see Venus now as a great crescent hanging in space, the sunlight illuminating just a curving sliver of its cloud veil, the rest of the globe in shadow. It's a serene and mesmerizing sight. With that image imprinted in your thoughts, you gently prepare to leave Venus behind. You begin to drift farther outward, leaving the bright cloud tops and the soft golden glow of this planet's atmosphere. Venus gradually becomes a smaller, pale pearl behind you. Ahead, the darkness of space is punctuated by a vibrant blue shine. The sight of it brings a comforting familiarity and a surge of warmth to your heart. It is our home, the Earth, glowing like a sapphire set in the night. The blue oasis of life in an otherwise austere solar system lies before you, waiting with open arms, with calm anticipation and a sense of coming home. You glide onward to Earth, eager to bask in the colours and life that await there. As you approach the Earth, a breathtaking sight unfolds before you. Hanging in the void Our home planet shines with a vivid beauty unlike any other. A swirling marble of blue, white, and green, the Earth appears both majestic and deeply inviting. From space, you see the vast expanses of the oceans, a rich, deep blue, sparkling where the sun's light dances on waves. Great swaths of white clouds coil and stretch across the atmosphere, their tops glowing brilliantly in the sunlight and casting soft shadows on the surface below. Between the blue of the seas and the white of the clouds lie the continents, patches of warm green and brown, the colours of forests, plains, and deserts. At the poles, caps of dazzling white mark the realms of ice and snow. Encircling the globe is a fragile, glowing halo, a thin blue line of atmosphere, the delicate envelope of air that makes all life here possible. Drifting closer, you are struck by how alive Earth looks, even from afar. Those white clouds slowly shift and churn with the weather, hinting at dynamic dances of storms and breezes taking place below. You notice a massive spiral of clouds over the ocean, a hurricane, majestic and silent from up here, turning like a great pinwheel. Elsewhere, a long band of clouds traces a cold front across a continent, and puffy cotton ball clusters speckle the tropics, where warm seas give rise to afternoon showers. Despite the power of these weather systems, from this vantage, they seem gentle, part of Earth's natural rhythms. The planet you see is active and ever-changing, yet harmonious in its movements. As the Earth rotates beneath you, different lands come into view. The golden deserts of Africa glow under the sun, then pass into dusk as the planet turns. The deep emerald of the Amazon rainforest emerges, and beyond it, the wide Pacific Ocean, dotted with bright swirls of cloud. You feel a sense of connection and pride, knowing that down on those diverse landscapes, countless forms of life are thriving. Forests filled with the whisper of leaves and the songs of birds. Savannas where herds of animals roam under the open sky. Vast oceans teeming with mysterious creatures dancing in the currents. All of that life, in all its complexity, is contained on that beautiful sphere below. On the night side of Earth, a different kind of light reveals itself. As the sunlit half of the globe slips away, twilight paints the edges of the continents in a gentle gradient from blue to deep indigo. Then darkness covers the land, and gradually tiny sparks of light appear where cities glow. Through the dark, you see the outlines of continents, picked out by a faint web of human lights. Clusters and tendrils following coastlines and winding along river valleys. From this cosmic vantage, there are no borders dividing these lands. Only one world united under the stars. The sight is subtle and enchanting. Unlike the cold, barren nightscapes of Mercury or Venus, Earth's night side twinkles softly with the presence of life and civilization. You imagine people down there, in those glowing towns and cities, living out their evenings under the same stars that now surround you. The thought brings a sense of companionship to the vastness of space, as if Earth is signaling that you are not alone out here. Home is always shining, waiting for your return. Across the darkened hemisphere, you also notice brief flashes of light in the clouds. These are thunderstorms seen from above, silent bursts of lightning illuminating the cloud masses from within. They flicker on and off like the gentle pulse of fireflies, hinting at rain falling over distant forests or plains. Near the poles, you witness a breathtaking phenomenon. curtains of ethereal green and red light swaying gently in the upper atmosphere. These are the auroras, the northern and southern lights, caused by particles from the sun interacting with Earth's magnetic field. From space, they appear as vast, shimmering veils of light dancing at the edge of the atmosphere. It's a silent, celestial ballet that crowns the planet's night side with beauty, ebbing and flowing in ghostly hues and casting a soft glow on the polar regions below. Looking at Earth from this high vantage, you feel a profound sense of peace and gratitude. That shining sphere holds everything we know: the oceans that cradle life, the lands where we took our first steps, the air that we breathe each moment without thinking. You reflect on how perfectly balanced Earth is, bathed in just the right amount of sunlight, covered in water, shielded by air. It is a sanctuary in space, a garden where life not only exists, but flourishes. In contrast to the stark landscapes of the Moon or the scorching atmospheres of Mercury and Venus, Earth is mild and nurturing. It is warm, but not boiling, cool, but not frozen solid. Just the right conditions for clouds to rain fresh water, for plants to grow, for creatures to roam. Out of all the planets you've seen, this one is uniquely alive, a true oasis. For a moment, you allow yourself to remember what it feels like to be on Earth's surface. As you float above the world, you imagine descending softly through that gauzy atmosphere. You picture white clouds parting around you as you glide down. Soon you're hovering just above a calm ocean at dawn. Gentle waves roll below, their surfaces turning gold with the first light of morning. You can almost hear the rhythmic hush of the surf and feel the cool, salty breeze brushing against your face. In the distance, gulls might be crying faintly as they ride the breeze. The sky above is painted with pastel shades of pink and pale orange. It's a scene of utter tranquility, one small glimpse of Earth's countless peaceful moments. Now your mind carries you over a lush green forest in summertime. You drift above the treetops, where sunlight filters down through a canopy of leaves, the air rich with the scent of greenery and warm earth. Perhaps you hear the soft rustle of foliage as a gentle wind passes, or the distant trickle of a stream winding through the woods. Each breath of that humid, woodsy air feels healing and full of life. As day turns to evening in this forest, fireflies begin to wink among the ferns, tiny lanterns blinking quietly as dusk settles. The earth is full of these little miracles, quiet scenes of calm and splendor happening everywhere, at every moment. In another moment, you drift in your imagination beneath the gentle waves of a tropical sea. Sunlight cascades through the water in shimmering shafts, illuminating a garden of corals below. You float effortlessly in the warm, crystal-clear water as schools of tiny, colourful fish glide by without fear. The world here is hushed and slow. You can hear only the soft sound of your own breath and the distant, soothing rumble of the ocean. Rainbow-hued fish weave through swaying sea anemones, and a curious sea turtle glides past with graceful, unhurried strokes. Overhead, the rippled surface of the sea separates you from the sky, and you watch as it dances with patterns of light. A sense of weightless tranquility envelops you, as if you are a part of the sea itself, moving in time with the gentle currents. In this underwater sanctuary, the bustle of the world above is forgotten, and only peace remains. With another thought, you find yourself on a quiet mountainside at twilight. The rocks beneath you are solid and reassuring. Far below, a valley is cloaked in dusk, and lights from a small village sparkle like stars in the darkness. Above, the first stars of night emerge in a sky still holding a faint glow from the set sun. You feel the crisp, cool mountain air fill your lungs. The scent of pine and a hint of wildflowers drift by. All is still, except perhaps a distant brook and the soft whisper of the wind through the branches. Standing there in your mind, you feel grounded and secure. One tiny being embraced by the vast earth. Now picture yourself in the far north on a clear winter night. A thick blanket of snow covers gentle hills and frozen lakes around you, muffling every sound. The air is stinging cold, yet your body is comfortably warm in this imagining. Under your feet, the snow crunches softly as you walk into an open field that sparkles with ice crystals. Above, the sky is midnight blue and filled with stars that shimmer brightly in the frigid clarity. A magnificent aurora spreads across the heavens, a curtain of soft green light undulating slowly from horizon to horizon. It shimmers and waves in silence, casting a faint emerald glow on the snowy ground. You pause and breathe deeply, your breath forming a gentle cloud that drifts away. In the profound stillness, you feel the deep peace of this polar night, a tranquility so complete it seems time itself has slowed. You stand enthralled by the cosmic light show above, feeling utterly safe and at peace in the pristine silence. As these visions of Earth's beauty play gently in your thoughts, you carry with you the calm and comfort they bring. You realize that no matter how far you travel in the cosmos, Earth remains your home, a place of deep solace and belonging. The entire world below, every ocean wave, every grain of sand, every living creature, every loved one, contributes to that feeling of home. In this relaxed state, you appreciate Earth in a way that is both intimate and expansive, as if seeing it for the first time, yet knowing it profoundly. Gradually, your awareness returns to your vantage point high above the planet. You gaze once more upon the whole Earth, turning slowly in the sunlight, half in day and half in night. A thin line of dawn is creeping over the dark hemisphere, bringing morning to another part of the world. The continuity of it all, the ceaseless yet gentle rotation, reassures you. Life moves in cycles, night to day, season to season, in a steady rhythm that has gone on for eons. Now, as much as you might wish to linger by Earth's side, the journey through the solar system calls you onward. With a final, loving glance at the blue marble below, you begin to drift farther away, slowly leaving Earth. The planet grows smaller, though it remains bright and beautiful, a radiant blue star behind you. As you pull back, you notice just off to the side of Earth, a smaller companion world coming into clearer view. The Moon, Earth's faithful satellite, appears as a large, pearl-grey orb circling our planet. In the sunlight, you can see its barren, cratered surface, so different from the vibrant Earth's. Yet the Moon has a gentle beauty of its own, glowing softly with reflected light, It has kept watch over Earth's nights for billions of years. You draw nearer to the moon, and it fills your view with its quiet, silver-grey presence. The moon has accompanied Earth for ages, orbiting around our world in a cosmic waltz, and now you drift beside it, ready to bask in Luna's gentle glow as it hangs next to our home world in space. Its surface is stark and serene. Against the deep black of space, the moon's face is painted in shades of grey and white. You see bright highland regions pocked with countless craters and darker, smoother patches that form vast circular plains. Those dark regions are the lunar Maria, Latin for seas, though they hold no water. They are ancient fields of solidified lava from volcanoes long extinct, great expanses that early skywatchers mistook for oceans on the moon. One of them, the Sea of Tranquility, lies quietly just below the moon's equator, a broad, dark expanse that looks especially peaceful, fitting for its name. Suspended above the moon's mottled terrain, you let your eyes trace the enormous craters etched into its surface. Some are tiny pits, others are giant basins with proud central peaks formed by colossal impacts eons ago. Around a few of the largest craters, you can make out bright streaks of material radiating outward. Long rays that stretch across hundreds of miles, evidence of meteor strikes that scarred the moon long before human life began on Earth. Because there is no atmosphere or weather on the moon, these scars never fade. There is no wind to erase the marks of meteor impacts, or even the footprints of astronauts. Everything that touches the moon's surface leaves a lasting impression, preserved in the silent, airless stillness. The moon's horizon is much nearer than Earth's, owing to the moon's smaller size. If you were standing on the lunar surface, the horizon would only be a couple of miles away. Beyond that, the ground would fall away sharply into the sky. You imagine what it would be like to stand on that surface now. Envision yourself gently touching down on a soft, powdery plain of grey dust. The ground is covered in fine, charcoal-coloured powder that puffs up slightly around your boots. All around, the landscape undulates with low hills and crater rims under a sky that is utterly black, even when the sun is shining. The sunlight is bright on the grey ground, but above you, no air scatters its rays, so the sky remains a deep, star-spangled void. In this imagined moment on the moon, an incredible sight hangs in the sky above the horizon: the Earth. From the moon's near side, the Earth appears as a magnificent blue and white sphere, much larger in the sky than the moon looks from Earth. It doesn't rise or set here, since the same side of the moon always faces Earth. Instead, the Earth hovers in nearly the same spot in the lunar sky, rotating slowly through its days and nights. Its swirling clouds and blue oceans in plain view. You could gaze up and see the dance of Earth's weather systems, the glint of sunlight on its seas, and perhaps even the faint glow of its atmosphere. That beautiful Earth light bathes the lunar landscape in a dim blue glow, just as moonlight softly illuminates Earth's nights. Here on the moon, the Earth itself is a radiant lantern in the sky, illuminating the dark ground with its gentle light. Standing on the moon, you would find the silence absolute. Without any air, there is no sound of wind, no rustling of leaves, no water flowing, nothing but the soft echo of your own heartbeat and breath within your suit. The stillness is profound, like being inside a great cosmic cathedral of ancient rock. The only motion you might notice is a lazy dust mote drifting if disturbed. Or perhaps far away, a tiny meteor silently streaking down to create a new crater. Time feels different here. A single moment on the moon can feel timeless. Days last 2 weeks, and nights the same. Long stretches of brilliant sunlight, followed by equally long stretches of darkness and cold. But in this moment of our journey, imagine the moon's surface gently lit by the sun, hanging low in the sky, casting elongated blue-black shadows across the ground. It's neither full daylight nor full night, perhaps a lunar dawn, with the sun just peeking above a crater's edge, bringing light to the dusty plains inch by inch. You recall that humans have actually been here, leaving footprints and little mementos. In a few places on this vast, untouched globe, the remnants of human visits rest quietly, footprints pressed into the powdery soil, scientific instruments long since silent, and flags standing motionless, untouched by any breeze. Those sites are tiny oases of history amid an ocean of untouched wilderness. Decades have passed since astronauts walked here, yet up here nothing has changed. The footprints have not eroded. The flags still stand, their colours slowly fading under unfiltered sunlight. It's comforting to think of those brave steps preserved here, a testament to human exploration, quietly awaiting the day someone returns. From where you float above the moon, you take in its overall form. The half of the moon facing the sun is brilliantly illuminated, almost blinding in its brightness, while the far side behind is engulfed in darkness. Along the line between day and night on the lunar surface, every crater and mountain stands out in sharp relief, their long shadows giving depth to the barren terrain. It's along this line between light and dark that the lunar landscape is most breathtaking, with intense sunlight and deep shadow side by side. For ages, humanity saw only the moon's near side and wondered what lay on the far side, forever hidden. When spacecraft finally ventured around the moon, they found that hidden face covered with endless craters, without the familiar dark seas that mark the side we see. Even our familiar moon keeps some secrets on its far side. Seeing the whole picture reminds you of the moon's phases as observed from Earth. Sometimes a slender crescent with most of the moon in night, other times a full moon when the near side is fully lit. Thinking of those phases brings to mind the moon's gentle glow as seen from Earth. You envision a clear night back on your home planet, with a full moon rising above the horizon. Its face shines down with a soft, silvery radiance, lighting up the world in a pale glow. Perhaps you picture moonlight filtering through your bedroom window, or spilling across a quiet meadow, or reflecting in shimmering columns on a calm lake. That light is the very sunlight you see now, reflected off the moon's chalky surface and sent to Earth as a nocturnal gift. For millennia, the moon's glow has guided night travellers, marked the rhythms of time in months, and inspired countless hearts with its beauty. Its gentle gravitational pull draws Earth's oceans into a slow, steady rhythm as well. The tides, endlessly rising and falling like the planet's peaceful breath. There is something deeply reassuring about the constancy of the moon, always cycling through its phases, always returning to fullness, always there in the night sky as a familiar companion. As you float above the moon's terrain, you let all these impressions wash over you. The extreme stillness of the lunar surface, the soft glow it casts onto Earth's nights, the intimate connection it shares with our home world. You feel a gentle affection for this desolate yet lovely place. In its silence, it offers peace. in its eternal face turned toward Earth. It offers companionship across the emptiness. Now, with one last look at the moon's stark and tranquil landscape, you prepare to venture farther out once more. In the distance beyond the moon, the black sky is spangled with stars, and just barely visible is a faint, reddish dot waiting for your visit. That tiny ember of rusty light is Mars, the next step on our cosmic journey. The moon slowly recedes behind you as you set your sights on the red planet, the crimson wanderer shining faintly ahead. With a calm and curious heart, you drift onward, leaving Earth's embrace entirely and heading into the deeper reaches of space toward Mars. Mars grows steadily larger as you approach, transforming from a tiny red pinprick in the distance to a distinct world before your eyes. The planet's colour is a warm, dusty hue of orange-red, earning it the nickname, the Red Planet. Its appearance is strikingly different from Earth's vibrant blues and Venus's pearly whites. Mars looks arid and weathered, like a rusty desert globe suspended in space. As sunlight falls upon it, you notice subtle variations in its colouring, lighter salmon tones where vast deserts of fine dust stretch out, and darker rusty brown patches where ancient volcanic rock covers the ground. At the poles, you can just make out caps of brilliant white. These polar caps of ice and frozen carbon dioxide grow and shrink with the Martian seasons, a reminder that even this cold desert world has its cycles of change. Drawing closer, you begin to discern prominent features on the Martian surface. A massive canyon system gouges a tremendous scar near the equator. The Great Valles Marineris, a chasm so vast and deep that it would stretch across an entire continent on Earth. If you stood at its rim, the opposite side would lie beyond the horizon, and the canyon's floor would be miles below, cloaked in bluish haze and shadow. Near this canyon, the smooth swell of an enormous volcano rises gently from the surrounding plains. Olympus Mons, the tallest mountain in the solar system, its summit piercing high above the Martian surface. Though 3 times taller than Everest, Olympus Mons is so broad and its slopes so gradual that if you stood on its flank, you might not even realize you were on a mountain at all. Countless other craters, hills, and sinuous dried river channels crisscross the planet, telling a story of a world that was once geologically active and perhaps even wet. Mars is smaller than Earth, about half the diameter, so its gravity is weaker and its atmosphere far thinner. You descend slowly through that thin atmosphere now, dropping toward a ruddy plain. The air is cold and tenuous, whispering faintly around you as you approach the ground. Below, the landscape comes into sharp focus, a barren expanse of coppery sand and dust, strewn with rocks of all sizes. You touch down lightly on Martian soil, and the scene that greets you is both alien and oddly familiar. It recalls deserts on Earth, perhaps the red sands of the American Southwest, or the dry valleys of Antarctica. Yet, there are no plants, no animals, no sounds of life. The silence here is deeper than any earthly silence. Under the afternoon sun, the sky on Mars is not blue, but a butterscotch orange-brown, coloured by fine dust suspended in the air. The sun itself appears smaller and gentler than it does from Earth, shining with a bright but slightly softer light in the tinted sky. Its warmth on your suit is present, but faint in the thin air. You begin to walk, in your mind, across the Martian terrain. With each step, pale red dust puffs up around your feet and settles slowly. The gravity is only about 1/3 of Earth's, so you feel light on your feet. In the distance, jagged hills mark the edge of an ancient crater. Above them, a high, thin cloud, made of ice crystals, stretches across the sky, catching the sunlight. As the day wears on, imagine the sun sinking toward the horizon of this world. The temperature, already chill even at noon, begins to drop further. In the east, the sky starts to take on a deeper hue. Sunset on Mars brings a surprising sight. While the horizon around the setting sun glows a faint bluish colour, the rest of the sky overhead fades to a reddish-grey twilight. When the sun finally dips below the horizon, the brief blue glow near the sun's last light vanishes, and a cold darkness settles over the desert. The temperature plummets quickly in the thin atmosphere. You pull your arms around yourself. In this imagined scenario, you feel no danger or discomfort, only the noted change in environment, and look up as the first stars appear. Remarkably, they look much as they do from Earth, except they don't twinkle quite as much, since the Martian air is so thin and still. Soon the sky is filled with the same ancient constellations, shining down on a new landscape. Where the sun has set, a few stars of evening twinkle, and among them you notice a particularly bright point with a steady golden glow. That is Jupiter, far beyond Mars, making its presence known, a destination for another journey perhaps. As night deepens on Mars, you might witness a gentle, otherworldly sight. One of Mars's 2 small moons, Phobos, rising swiftly in the sky. Phobos is tiny and irregularly shaped, more like a captured asteroid than a large moon, and it moves quickly. In just a few hours, it crosses from horizon to horizon, a speeding little star-like dot. The other moon, Deimos, is even smaller and fainter, taking a more leisurely path overhead. They are not grand beacons like Earth's moon, but they are constant companions in the Martian sky, racing around the planet as if keeping watch over the quiet landscape. Standing on the Martian surface, you feel an undeniable sense of calm and solitude. The silence is profound. Only the crunch of your footsteps, and perhaps the whisper of a cold breeze stirring the dust, break the stillness. That breeze, though faint, can sometimes swirl into a dust devil, a miniature whirlwind that dances across the plains, twisting a thin column of sand high into the air. You see one in the distance now, a ghostly funnel of dust silently tracing its way across the horizon before it fades and the particles gently fall back to the ground. Mars may be largely quiet now, but it is not static. The planet breathes in its own way, with these occasional gusts and shifting sands that slowly, subtly reshape the surface over time. As you gaze across this desolate beauty, you can't help but wonder about the Mars that once was. Scientists believe that billions of years ago, Mars was warmer and wetter than it is today. Dry riverbeds etch the surface, and minerals that only form in liquid water have been found in Martian rocks. Perhaps long ago, clear rivers flowed through what are now barren valleys, and shallow lakes glittered under a younger sun. One might imagine an ancient Martian dawn with mists rising off a lake, or rain gently falling on red rock, a time when Mars was more Earth-like. Those days are gone, and Mars has since become a frozen desert, but the evidence of that lost era remains like a whisper in the stones. The thought stirs a quiet awe within you. Worlds, like living things, have histories and chapters. Mars's story is written in this hushed landscape of red dust and rock. The ancients named this planet Mars, after the god of war, because of its blood-red colour in the sky. But standing here now, you sense no war or conflict, only peace and antiquity. The red hue comes from iron in the soil rusting over eons, blanketing the planet in a soft, rusty powder. In the thin air, everything is muted and gentle. Mars is a world that knew great turmoil in its deep past. Volcanoes that built towering mountains, impacts that carved giant craters, floods that may have rushed through canyons. But now it has entered a long, quiet rest. It rotates on its axis every 24.6 hours. So a Martian day, or sol, is just slightly longer than an Earth day, giving a familiar rhythm to the cycle of light and dark. Seasons come and go, causing the polar ice to grow and shrink, and occasionally a global dust storm will enshroud the entire planet in a tawny haze. But on this tranquil evening, as you stand on the Martian soil, all is still. The stars above are steady, and the faint band of the Milky Way can be seen stretching across the sky if you look carefully, a reminder that even here you are under the same galaxy-spanning night as on Earth. For a moment, you close your eyes and simply feel the profound quiet of this place. In that silence, you might imagine faint echoes of a distant future, perhaps the soft voices of humans in a habitat not far from here, or footsteps crunching in this same dust as future explorers turn what we now dream into reality. Already, humanity's touch has begun to reach Mars in small ways. Even now, there are a few robotic rovers and landers on these sands, mechanical envoys from Earth. One rover far away might be slowly trundling up the slope of a crater, diligently examining the rocks in its path as the late afternoon shadows lengthen. Another has long gone still, its mission complete, sitting quietly in the lonely twilight. The tire tracks and footpads of these machines crisscross parts of the terrain, a humble record of our curiosity etched into the dust. In time, the wind will cover them and make the surface new again. But for now, they remain, evidence that we have begun to gently extend our reach to this world. One day, footprints may join those tracks, and a new chapter of Mars's story will begin. You open your eyes and find Mars again, spread out before you, ancient and patient. Overhead, the sky has darkened to an almost moonless black. The temperature is far below freezing now, and a delicate frost might be forming on the coldest rocks. Far on the horizon, you see the sun's last rays catching the top of a distant crater rim, a brief orange glow that quickly yields to night. And there, rising into the sky, you spot Earth. From Mars, our home planet appears as a bright bluish-white star low above the twilight horizon, a tiny beacon of life shining across tens of millions of miles. The sight brings a gentle smile to your face. For all the beauty and wonder of these other worlds, Earth is uniquely warm and inviting, a reminder of where you come from and where comfort forever resides. Now, with Mars softly behind you, and Earth just a distant glimmer, you feel the pull of rest calling you. You begin to drift upward once more, leaving the Martian surface. The red planet becomes a smaller and smaller disk below, until it is just another reddish star in the starry expanse. You have journeyed through the inner solar system, from the sun's fiery glow to Mercury's extremes, to Venus's veil of clouds, to Earth's living paradise and its gentle moon, and finally to Mars's quiet deserts. Each of these places now feels like an old friend, each shining in your memory with its own hue and personality. Continuing outward from Mars's orbit, you drift into a sparse field of ancient stones. The asteroid belt. Countless rocks and minor planets circle here, remnants of the solar system's birth. Some are no bigger than pebbles. Others are hundreds of miles across. They float in solitude, occasionally catching the sunlight and winking like distant stars as you glide past them. This gentle sea of asteroids is calm and silent, a gateway between the inner worlds you've visited and the outer realms to come. Far beyond this belt lie the giant outer planets and countless other marvels awaiting in the darkness. They beckon from afar, Jupiter, Saturn, and the worlds beyond, each glimmering like a distant lantern in the cosmic night. Out beyond Mars, beyond even where you are now, lie those outer planets and more wonders waiting to be explored. But those will be for another voyage, another night. For now, you allow yourself to simply float in the peaceful space between worlds. You are drifting in starlight, content and at ease, with the quiet heartbeat of the cosmos all around you. In the vast silence, you feel a profound connection to the universe and a deep tranquility within. The steady rise and fall of your breath echoes the slow rhythm of the cosmos. Every muscle in your body is loose and weightless. The stars gently twinkle. Mars shines with its soft red glow nearby, and Earth's faint spark glitters from afar. In this moment, you are utterly relaxed, completely safe, and cradled by the cosmos itself. You allow your eyes to grow heavy and softly close, still seeing the gentle starlight in your mind. You carry all the wonders of the solar system in your heart, their peace now a part of you. Under the eternal night sky, you let your thoughts float like a gentle cloud, drifting and drifting. You sink into a deep, comfortable sleep, embraced by the infinite peace of the stars. Out of the star-strewn darkness ahead, a faint speck of light has been growing steadily brighter. As you draw nearer, it resolves into a colossal striped sphere hanging in the void. Jupiter now looms before you, the king of the planets, basking in the distant sunlight. It is an awe-inspiring sight, a giant of swirling clouds and subtle colours, silently dominating its corner of the cosmos. You drift closer and closer, and Jupiter expands to fill your view. The planet's immense size becomes more apparent with each passing moment. Its curved horizon stretches far wider than any world you've seen before. Bands of amber, ivory, and russet wrap around Jupiter's circumference in broad stripes. These are belts of clouds, flowing east and west at tremendous speeds, high in Jupiter's atmosphere. They interweave in a mesmerizing pattern, like a marbled canvas of cream and copper. In the gentle sunlight out here, those cloud bands glow softly, their colours muted and blended by a thin haze. The sight is both majestic, and strangely calming. The enormous planet turning slowly before you in perfect silence. Despite its tranquil appearance from afar, Jupiter's atmosphere is in perpetual motion. You sense the power in those clouds, an endless dance of storms and winds churning beneath the peaceful facade. As you glide above the cloud tops, you notice patterns form and fade, whirls of white where ammonia clouds billow high, and darker ribbons where the clouds sink low. In some regions, subtle swirls and eddies create beautiful oval shapes in the cloud layers. One particular feature draws your eye: a great oval storm, brick red in hue, embedded among the southern cloud belts. This is the Great Red Spot, a colossal cyclone that has raged in Jupiter's atmosphere for centuries. It rotates slowly, completing a wide circle every few days, and is so large that it could swallow the Earth whole. Yet from your vantage point, it is just one jewel in Jupiter's vast tapestry of weather. Jupiter's rapid rotation also subtly reveals itself as you watch. A full day on Jupiter lasts less than 10 hours, so the planet turns at a tremendous rate. If you fix your gaze on the Great Red Spot or another feature, and observe for a while, you realize it is shifting position, carried along as Jupiter spins from west to east. In only a few hours, entire weather systems that were on the horizon move across the planet's face. This dizzying speed causes Jupiter to bulge slightly at its equator and flatten at the poles. But to your eyes, it remains a grand, immense globe, regal in its motion. You hover in the thin upper atmosphere now, letting the spectacle unfold below. High above Jupiter's clouds, the sunlight is dim and tinged with gold. The sun is far away here, only a small, bright star compared to the warm light we know on Earth, but it still bathes Jupiter in a gentle glow. In the twilight of the cloud tops, you glimpse occasional flickers of light, distant lightning illuminating the storm clouds from within. For brief moments, a swirl of clouds lights up, then fades back into the soft gloom. In the vacuum of space, you hear nothing of these storms. All is quiet, and the fury of Jupiter's weather is rendered strangely peaceful when observed from afar. As Jupiter turns beneath you, day slowly gives way to night across its immense face. The line between day and night gradually drifts over the cloud tops, bringing dusk to one side of the planet and dawn to the other. On the night side, the planet is lit by a faint ethereal glow. Jupiter's own internal heat seeps out from below, and high above the darkened clouds, you see ghostly auroras shimmering around the poles. Curtains of electric blue and violet light dance silently at Jupiter's north and south poles, where the planet's powerful magnetic field draws in charged particles from the sun. These polar lights flicker and gleam, outlining an immense magnetic halo around the giant world. It's a silent cosmic light show, an aurora far larger than any found on Earth, crowning the swirling clouds with a mysterious glow. Suspended here above Jupiter, you feel the immense gravity of this world gently tugging at you, reminding you of the planet's dominance. Jupiter is truly massive, more than twice the mass of all the other planets combined. It formed in the dawn of the solar system, and for billions of years, it has held court here in the outer reaches, influencing everything that wanders by. Comets and asteroids that stray too close are captured or flung away by its gravitational might. It is as if Jupiter stands guard over the inner planets, sweeping up debris and protecting them from cosmic harm. In its domain, everything bends to the will of this king of planets. Circling around Jupiter is a retinue of moons, dozens upon dozens of them, from tiny asteroidal rocks to enormous moons the size of small planets. As you gaze outward from the planet, you catch sight of a few bright points of light moving against the starry background. These are Jupiter's largest moons, the 4 Galilean satellites, each a fascinating world of its own. The innermost, Io, is a small golden-hued orb that travels closest to Jupiter. If you look closely, you can just make out a faint haze around Io, evidence of its active volcanoes. Io is alive and restless, the most volcanically active place in the solar system. Under Jupiter's immense gravitational pull, Io's interior heats up, causing molten sulfur to erupt from hundreds of volcanoes on its surface. From here, you can occasionally see a delicate plume arcing above Io's horizon, a silent fountain of sulfur gas and dust rising high before gently falling back down. These eruptions happen in silence out here, and the plumes drift slowly in the weak gravity, a graceful display of cosmic fireworks, quietly painting Io's surface anew. Further out, another moon catches the sunlight. Europa. Europa gleams like a pale ivory disk. Its surface is smooth and bright, covered in a shell of water ice. You notice a network of fine, tawny lines crisscrossing that moon, long cracks in the ice, hinting at a deep ocean hidden below. Europa's frozen crust hides a global ocean of liquid water, kept warm by the same tidal forces that drive Io's volcanoes. It is an ocean that has never known sunlight, sealed beneath miles of ice, and yet it may harbour the ingredients for life in its dark depths. As you contemplate this mysterious ocean world, you imagine the scene on its surface. If you were standing on Europa's icy plains, the sky above would be dominated by Jupiter. The giant planet would hang there, immense and banded, illuminating Europa's night with a soft, pearly glow. It must be a breathtaking sight. Jupiter's swirling face filling the sky, casting dim light across the frozen ground. Beyond Europa lies Ganymede, the largest of Jupiter's moons, indeed the largest moon in the entire solar system. Ganymede appears as a grey-brown globe, even larger than the planet Mercury. Through your eyes, Ganymede's surface looks patchy, marked with lighter regions of ice and darker patches of ancient, rocky terrain. This moon even has a faint gleam of frost at its poles. Ganymede is a giant among moons, so large that it generates a magnetic field of its own within its hidden metallic core. It is a world of rock and ice, with possibly an ocean deep beneath its crust as well, and a thin whisper of atmosphere above. If you drifted above Ganymede's lonely surface, you would see Jupiter rising beyond its horizon, casting a ghostly light over countless craters and grooves. Ganymede's landscape is old and silent, marked by time and the slow shifting of ice over billions of years. Further out still, on the fringes of Jupiter's realm, is Callisto. Callisto orbits far from Jupiter and appears as a dim, dusky sphere speckled with bright white spots. Those spots are the peaks of craters, catching the sunlight on an otherwise dark, ancient surface. Callisto is a heavily cratered world, a moon that has changed little in over 4 billion years. Its surface is like a cosmic time capsule, preserving the record of countless meteor impacts from the early days of the solar system. Floating above Callisto, the quiet would be profound. From this far vantage point, Jupiter appears smaller, though still majestic, hanging in Callisto's sky with a subdued glow. The stars beyond shine clearly, as Callisto lies nearly at the edge of Jupiter's domain. a silent outpost of the Jovian system, forever gazing out into the broader cosmos. All these moons move in a clockwork dance around Jupiter. From where you hover, you can see them tracing their paths. Io, racing around quickly, while the outer moons move more leisurely. Occasionally, one of these moons casts its shadow onto Jupiter's cloud tops, creating a tiny eclipse that glides across the face of the giant planet. If you are lucky, you might witness a double spectacle. Perhaps Europa, emerging from behind Jupiter, just as Io's round shadow slides across the striped clouds below. These celestial motions play out in stately silence, a ballet of worlds moving to the silent music of gravity, all illuminated by the distant sun. Watching this miniature solar system in action, you are struck by how Jupiter and its moons resemble a small version of the Sun with its planets. The 4 large moons, each so different, all orbiting in Jupiter's grip, bring to mind the way our own Earth and neighbouring planets orbit the Sun. In this Jovian system, you see an echo of the solar system structure on a smaller scale, a central titan with a family of worlds swirling around it. Being here instills a profound sense of perspective. Our Earth, with all its life and history, would be just a tiny speck next to this immense planet. Yet here you see worlds upon worlds in Jupiter's embrace, each contributing to the grand cosmic tapestry. Drifting in the presence of Jupiter, you feel both humbled and at peace, aware of the grandeur of nature on a scale far beyond your familiar home. The gentle rotation of Jupiter, the timeless orbiting of its moons, and the delicate auroras dancing at its poles all impart a feeling of cosmic harmony. It is as if you are witnessing a symphony of motion and light that has played for eons, a silent anthem to the vastness of the solar system. After spending a long and tranquil time in the realm of Jupiter and its moons, you feel the pull of the journey onward. At length, you prepare to continue farther out into the solar system. You take one last, lingering look at Jupiter's immense form. The great red spot still swirls, centuries old and persistent, a deep russet oval against bands of white and ochre. Along Jupiter's horizon, dawn is spreading once more, lighting up the tops of the highest clouds in hues of rose and gold. In that dim morning light, Jupiter's colours soften to pastel shades. The giant appears peaceful and gentle, a sleeping colossus beneath gauzy veils of cloud. Encircling the planet's middle, you notice a delicate treasure often overlooked: Jupiter's rings. Unlike Saturn's broad, shining rings, Jupiter's rings are extremely thin and faint, made of fine dust and tiny bits of rock. At this angle, with the sunlight behind them, they become visible as a slender, ghostly halo around the planet's equator. The ring is like a gossamer crown adorning Jupiter, a subtle band that glints ever so softly before blending again into darkness. It's a reminder that even this great planet wears a quiet adornment of its own, a nearly invisible wonder circling with the moons. Now Jupiter lies below and behind you, with the tiny lights of its moons still visible like fireflies orbiting a lantern. That magnificent world slowly begins to recede as you drift farther into space. The king of planets grows smaller in your view, its striped bands and great storm fading into a pale speck once again. Jupiter watches over your departure with its serene, unblinking presence, as if assuring you it will remain, patiently awaiting your return. Turning your gaze forward, you look toward the next destination on this cosmic voyage. Far ahead, across the expanse of the outer solar system, a pale golden light beckons against the starry blackness. It is not a star, but another planet, one famed for its breathtaking rings. You set your course toward that distant shimmer. Saturn, the ringed wonder of the solar system, awaits and calls you onward. You travel on through the silent gulf between Jupiter and Saturn. The stars around you are sharp and clear in the darkness. The sun is now even farther behind, its light gentler and more distant than before. For a time, you drift in this quiet, empty space with only the faint glow of starlight and the far-off glimmer of your destination. Gradually, that pale golden light ahead grows brighter. What was once a pinprick now stretches into an elongated shape. You realize you are beginning to see Saturn's rings edge on, a thin line of light bisecting the golden dot of the planet. Drawing closer, the thin line separates into a magnificent disk encircling a planet of soft, amber hues. At last, you arrive at Saturn, the jewel of the solar system, adorned with its breathtaking rings. Saturn floats before you, a giant world like Jupiter, yet distinct in its elegance. The planet itself is a beautiful sphere coloured in gentle tones of butterscotch and honey. Faint bands of cloud wrap around it, less contrasting than Jupiter's bold stripes, giving Saturn a more uniform, subdued appearance. There is a hazy band of white near its equator, and hints of gold and ochre toward the poles. Saturn's upper atmosphere looks cold and calm, though powerful winds are blowing beneath those clouds. In fact, jet streams race around Saturn at tremendous speeds, but from out here, everything appears placid and slow. Despite its vast size, Saturn has a surprisingly low density. It is often said that if there were a bathtub large enough, Saturn would float in it like a giant buoy. Of course, no such cosmic ocean exists, but the idea illustrates how Saturn is made mostly of light gases. It's less dense than water. This gives Saturn an almost delicate nature, despite its great bulk, as though it were a giant ball of golden cloud resting gently in space. Saturn's motion through the heavens is stately and slow. It takes nearly 30 Earth years for Saturn to complete a single orbit around the Sun. To ancient sky watchers, Saturn was the outermost known planet, moving so gradually that they associated it with Kronos, the god of time. Watching this serene planet now, you sense a timeless quality about it. Saturn has been circling in its distant path for eons, marking the long passage of years with each journey around the Sun. High in Saturn's northern latitudes, a curious feature persists in the cloud patterns, a vast six-sided swirl, a hexagonal storm system surrounding the North Pole. This enormous hexagon of clouds remains stable and mysterious, a geometric shape swirling amidst the otherwise smoothly curving bands. It's as if nature drew a subtle pattern on Saturn's crown, a quiet enigma in the planet's circulation. Elsewhere, subtle eddies and storms come and go, including rare great white spots that occasionally erupt and fade. But overall, Saturn's atmosphere displays a gentle, muted demeanor from your perspective. A giant, adorned in pastel hues, turning calmly in the sunlight. The crowning glory of Saturn is the system of rings that surrounds it. From a distance, the rings are luminous and broad, shining with an almost ethereal light. You adjust your vantage point, drifting above the plane of the rings to see them fully unveiled. Spread out below you is a flat, gleaming disk encircling Saturn's equator for hundreds of thousands of kilometers. The rings are astonishingly wide. You could line up several Earths across their span. Yet, they are incredibly thin, only a few tens of meters thick in most places. They gleam like a halo of light, divided into bands and gaps that form concentric patterns around Saturn. You see distinct ring regions separated by darker divisions, the most prominent being a broad gap called the Cassini division that splits the brightest rings. On the inner side of that gap lies the B ring, dense and brilliant, and outside it, the A ring, which tapers off at its outer edge. Closer to Saturn is the C ring, more translucent and faint. Beyond the main bright rings, you notice tenuous rings, whisper-thin veils of dust that extend farther out, including a distant diffuse ring discovered when a spacecraft flew through Saturn's system. Altogether, Saturn's rings form a complex and breathtaking structure, like the grooves of a giant cosmic record around a golden planet. As you glide just above the rings, you marvel at their beauty and symmetry. They are composed of countless individual pieces, billions upon billions of ice fragments and dust, each orbiting Saturn like a tiny moon. Some are as small as grains of sand, others as large as boulders or houses. From a distance, their collective brightness blends into solid bands. But up close, there are gaps and spaces between the particles. If you could venture nearer, you would see these chunks of ice sparkling like crystals as they catch the sunlight. Occasionally, two pieces might collide softly and break apart or stick together, but overall they move in unison, kept in orderly lanes by Saturn's gravity and the shepherding influence of small moons embedded within the rings. Indeed, here and there you can spot a miniature moonlet, only a few kilometers across, orbiting within a gap and sculpting a narrow lane in the ring material. These shepherd moons gently herd the ring particles, maintaining the sharply defined edges of Saturn's rings. It is a celestial dance of countless icy pieces, all circling in a flat plane, shimmering quietly as they go. Looking towards Saturn from above the rings, you see the planet's shadow cast across them. A broad, curved shadow cuts a dark swath over the rings on the side opposite the sun, reminding you that these graceful bands are made of countless particles blocking the sunlight. On the portion of the rings in shadow, everything is in darkness. If you were among the ring particles there, you would suddenly be surrounded by night until you drifted back into sunlight. Likewise, if you look at Saturn's cloud tops, you can discern the faint outline of the ring's shadow falling onto the planet, a wide, dim band encircling the creamy sphere. This interplay of light and shadow creates a serene pattern, as Saturn and its rings cast silhouettes on one another. It's a reminder of the cosmic geometry at work, the Sun, Saturn, and the rings aligning in a silent, moving sculpture of light. In the silence of space, the rings make no sound, but you can imagine the faint whisper of particles colliding, a soft hiss as fine ice grains brush past each other. The rings shine below you like a flattened rainbow of mostly white and cream, with subtle hints of colour. Some areas slightly tawny or grey, depending on the purity of the ice. In certain light, parts of the rings even show a faint pink or brownish tint, tinted by dust and other impurities. It's as if an artist lightly shaded sections of this broad, cosmic disk with pastels. The overall effect is mesmerizing, a hypnotic expanse of softly glowing bands that almost lulls you into a trance as you watch them. Beyond the main rings, Saturn is surrounded by more distant rings and arcs that are far fainter. One of these is the E ring, a very broad, diffuse ring far from Saturn. It has a special source, the moon Enceladus. Tiny particles erupt from Enceladus's geysers and spread out to form the misty E ring that glitters faintly in Saturn's outer realm. The existence of these far-flung rings adds another layer of wonder. Saturn is truly enveloped in ring material from near to far, an intricate set of disks and loops. As you continue to admire Saturn's rings, you imagine different perspectives from which to view them. If you were to slip just underneath the ring plane on the planet's night side, the rings would appear as a shimmering band across the sky, illuminated by sunlight, filtering through and by the soft glow of Saturn's reflected light. The stars would peek through the gaps, appearing and disappearing as the countless ring particles drifted past. From that vantage, the rings might look like a translucent arch stretching across darkness. Conversely, hovering above the sunlit side of the rings, you would see them sweep from one horizon to the other, a radiant bridge suspended in space. No matter where you position yourself, the spectacle of Saturn's rings is endlessly captivating. They draw you into a meditative state as you observe their perfect symmetry and the gentle grace of their orbital dance. The enchantment Saturn inspires is not new. Even from Earth, humans have long been mesmerized by this ringed world. Many people recall the first time they saw Saturn through a small telescope, appearing as a tiny golden orb with delicate rings, almost too exquisite to be real. That sense of wonder is only amplified now that you are here, up close. Saturn's beauty feels otherworldly, dreamlike, and you cherish the opportunity to witness it directly. In the quiet space around Saturn, you feel a deep calm. The planet, its rings, and its moons move in silent concert. You feel yourself a part of this celestial harmony, as if listening to an unseen symphony that has been playing for millennia. Eventually, you gently lift your gaze from the rings and turn to Saturn's family of moons, each a world in its own right. Saturn has a great many moons, more than 80 known, and they range from large spherical moons to little irregular chunks of ice and rock. The largest and perhaps most intriguing is Titan, a moon so big it rivals planets in size. Titan becomes visible now as a steady golden-orange orb moving around Saturn. You decide to visit this mysterious moon as well. Drifting toward Titan, you notice it growing from a dot into a substantial globe. Soon, you see it clearly. Titan is swathed in a thick atmosphere, completely obscuring its surface. Its color is a muted orange, as if a perpetual smoggy twilight blankets the entire moon. As you approach, the haze of Titan's atmosphere envelops you in a diffuse amber light. The sunlight here is weak and filtered through layers of cloud. If you descend into Titan's upper atmosphere, you find the air is dense and primarily nitrogen, like Earth's, but frigid and laced with methane. Everything is calm and muffled in Titan's skies. You cannot see the ground through the golden fog. But you know that far below, Titan's surface is unique among moons. There are lakes and seas of liquid methane and ethane spread across its polar regions, and rivers that once flowed, carving channels in the icy ground. Mountains of water ice stand firm in the deep cold. Occasionally, a gentle rain of methane drizzles from Titan's clouds, feeding those alien lakes. It is a world strangely reminiscent of Earth in its processes, with weather, rivers and lakes, but built from utterly different materials and existing in a deep freeze. Floating in Titan's upper atmosphere, you imagine what it might be like on the surface. The daylight would be dim, like early evening on Earth, even at noon. The sky would glow orange, and an eerie twilight would reign at all hours. Because of Titan's thick air and weak gravity, if you were equipped with wings, you might actually fly by your own power. Scientists have mused that human explorers could don winged suits and soar through Titan's sky, buoyed by the dense air. It's a dreamy thought, gliding in slow motion under an orange sky, above dark, ethane-filled lakes and icy plains. Far above the clouds, you know Saturn itself is present, but the haze hides it from view. Only a faint brighter patch in the perpetual overcast hints at where Saturn might be. Titan keeps its parent planet's face veiled behind its thick atmosphere, guarding the mysteries on its own surface. As you gently ascend out of Titan's haze once more, the majestic view of Saturn and its rings reappears, floating in space near Titan, like a celestial painting come to life. You leave Titan's alien skies behind and set your sights on another remarkable moon, the bright ice world of Enceladus. Enceladus is much smaller than Titan, only about 500 kilometers across, but it shines brilliantly white, like a pearl orbiting Saturn. Its surface is almost entirely covered in clean water ice, reflecting sunlight like fresh snow. Approaching Enceladus, you see that it is a tiny, bright sphere with a surface crisscrossed by fractures and regions of smooth young ice. Near Enceladus's south pole, an astonishing sight greets you. Dozens of fine jets of vapor and ice crystals are erupting from cracks in the moon's surface, streaming into space like geysers. These plumes are the source of the E-ring you noticed earlier. Water vapor and ice particles spray out in broad, gentle fountains, many falling back onto Enceladus as snow, and some escaping to form that diffuse ring around Saturn. You drift through one of these ethereal plumes, and it shimmers around you, like a cold mist glittering in the sunlight. In the vacuum, you feel nothing, but you see the tiny ice grains twinkling before they settle. It is a serene eruption. No sound, just a graceful venting of water that has been warmed and pressurized beneath Enceladus's surface. Beneath the ice under your feet lies a hidden ocean of liquid water, kept warm by tidal forces flexing the moon's interior as it orbits Saturn. These geysers are a sign of that subsurface sea, spraying its contents out through cracks in the crust. It's awe-inspiring to realize that beneath you on this little moon is a warm, dark ocean, possibly habitable, encased in ice, sending its emissaries of water out into space. Enceladus is like a cosmic snowball with a heartbeat, quietly breathing out water vapor into the void. Saturn has many other moons as well, each with its own character. There is Dione and Rhea, mid-sized moons with cratered surfaces and bright ice cliffs, silent for billions of years. There is Iapetus, a two-toned moon with one hemisphere as dark as coal and the other as bright as frost, giving it the appearance of a yin-yang in space. And there are numerous small moons, captured asteroids and fragments tumbling along in orbit around Saturn. Together, Saturn's moons form a diverse retinue, accompanying the ringed planet on its eternal journey around the Sun. They dot the space around Saturn like lanterns of various sizes, each reflecting sunlight as it goes, each contributing to the story of Saturn in its own way. In modern times, we have even sent a robotic explorer to Saturn. From 2004 to 2017, a spacecraft named Cassini orbited Saturn and studied its rings and moons in exquisite detail. Cassini flew through the gaps in the rings, landed a probe on Titan's surface, and revealed Enceladus's geysers up close, transforming our understanding of this system. In its final act, low on fuel, Cassini plunged into Saturn's atmosphere, burning up like a meteor to become part of the planet it had explored, a noble end to ensure Saturn's moons remained pristine. Thanks to Cassini's voyage, much of what you are witnessing now has been captured in photographs and data. Yet seeing Saturn's majesty with your own eyes, even in imagination, brings a personal sense of wonder that no image can fully convey. Having explored Saturn's enchanting rings and moons, you feel a deep sense of calm and wonder. The vision of this planet, the wide ethereal rings arching around a softly banded globe, is something you will carry with you forever. Saturn seems almost too beautiful to leave, suspended here in the starry darkness, like a dream made real. You take a moment to simply float and soak in the splendor, the silent expanse of the rings below, Saturn's gentle glow lighting them up, the myriad moons casting tiny gleams or shadows as they orbit. Time feels slow and syrupy here. It's easy to lose yourself watching the rings circle around in their endless loop. But eventually, your journey must continue. Gently, you drift farther from Saturn, moving above the ring plane once more. The great rings narrow back into a fine band of light encircling the planet. Saturn itself grows smaller, turning into a pale golden orb again. As you recede into the distance, the entire ring system looks like a delicate piece of jewelry, a gossamer circlet around a marble. The sun catches Saturn's rings at just the right angle, and for a moment they flash like a solitary halo in the dark. Little by little, the vision diminishes with distance. Saturn remains visible as a dwindling but beautiful point of light, until finally it is just another bright star behind you, mingling with the constellations. Ahead, the solar system stretches farther into the dark. You have now travelled so far from the sun that the inner worlds are invisible behind you. The sun itself is smaller and dimmer than ever, now just an intensely bright star in the distance. Yet your voyage is not over. There are still more planets to visit out here, in the cold twilight of the outer solar system. Leaving behind the golden glow of Saturn, you set your sights on the next destination. Farther out, where the sunlight is weak and blue, a giant planet, tipped on its side, awaits. With Saturn fading from view, you venture onward toward Uranus, the tilted giant, awaiting in the deep twilight. The journey from Saturn to Uranus is long and quiet. Far beyond Saturn's orbit, the darkness deepens further and the cold intensifies. The sun, now even more distant, appears only as a small bright star, its rays faintly illuminating the way. You travel through this silent stretch of space for what feels like ages, the void punctuated only by the dim glow of far-off stars. Slowly, a new speck of light grows in the darkness ahead. It is Uranus, and as you draw nearer, it resolves into a tiny disk with a delicate blue-green hue. At first glance, Uranus is unassuming, a dim, pale cyan orb suspended against the black backdrop. Indeed, it remained unknown to ancient astronomers, appearing only as a faint star in the sky until modern times. Not until 1781 did a British astronomer, William Herschel, recognize this speck as a new planet beyond Saturn. It was a discovery that expanded the known solar system for the first time in history. This distant world was eventually named Uranus, after the ancient god of the sky, an apt choice for a planet that itself looks like a piece of the sky, a softly glowing teal disk amidst the stars. Drifting nearer, you get a clearer view of the planet itself. Uranus is a vast world, about 4 times the diameter of Earth, an ice giant, smaller than Jupiter and Saturn, but still enormous compared to our home planet. Its colour is a gentle aquamarine, a pale greenish blue, like the tint of a tropical sea seen from high above. The disk of Uranus appears unusually smooth and uniform. There are no bold stripes or raging storms visible at first glance, just a tranquil, softly coloured sphere. The methane gas in Uranus's upper atmosphere absorbs red light from the distant sun, leaving the reflected sunlight tinted a cool blue-green. This gives Uranus its distinctive hue, a calm pastel tone that sets it apart from the golden clouds of Saturn or the banded turbulence of Jupiter. The atmosphere here is frigid. The cloud tops are around minus 220 degrees Celsius, and under these cold conditions, the weather is subdued. With careful attention, you can make out a few faint features, perhaps a thin white streak indicating a high-altitude methane ice cloud, or a diffuse brightening near the edge, hinting at a storm deep below. But overall, Uranus's appearance is placid and almost featureless to your eyes, like a global, calm sky. One of the most remarkable aspects of Uranus is immediately apparent. The planet is tilted over dramatically on its side. Its axis of rotation is tipped about 98 degrees relative to its orbit. Essentially, Uranus rotates like a sphere, rolling around the Sun. As you approach, you realize that one of Uranus's poles is pointed roughly in your direction. At this point in Uranus's long 84-year journey around the Sun, its northern hemisphere is tilted sunward, and its north pole is basking in continuous sunlight, while the south pole lies in endless darkness. This extreme tilt gives rise to the strangest seasons in the solar system. Each pole gets about 42 years of unbroken day, followed by 42 years of unbroken night, as Uranus slowly orbits the Sun. At the time you are visiting, one half of Uranus has been in a long summer day for decades, while the other half has languished in a frigid winter night. Eventually, as Uranus continues along its orbit, the roles will reverse. But the change is ponderously slow, happening on timescales far beyond an earthly lifetime. You reflect on how alien time and light behave on this distant planet. Seasons lasting longer than a human lifetime, day and night cycles stretching on for decades. It is a reminder of the vastness and variety of the solar system, where each world follows its own rhythm under the sun. Scientists suspect that an ancient cataclysm may be responsible for Uranus's peculiar orientation. Perhaps billions of years ago, a protoplanet struck Uranus with immense force, knocking it onto its side. Such a colossal impact could have also disrupted Uranus's interior, possibly explaining why this giant emits so little heat compared to its peers. Beneath the quiet clouds, the conditions inside Uranus become extreme. As you dive deeper, the hydrogen and helium atmosphere gives way to hot, dense fluids of water, methane, and ammonia. Pressures climb to staggering levels. In those depths, exotic processes might occur. Some scientists even theorize that carbon from methane could be compressed into diamonds that rain down through the fluid interior. Whether or not this literal diamond rain happens, It hints at how mysterious and alien the inner regions of Uranus are. So much is hidden beneath its gentle blue-green facade, locked away under crushing pressure and darkness. As you move in closer, you notice a series of narrow rings encircling Uranus's equator. Due to Uranus's sideways orientation, these rings appear almost like vertical hoops from your perspective. They are nothing like the broad, bright rings of Saturn. Uranus's rings are thin, dark, and subtle, composed of material that reflects very little sunlight. There are about 13 known rings, the brightest of which is called the Epsilon ring, a thin band of charcoal grey ice and rock that stands out slightly against the darkness. These rings were a secret hidden in the night until the late 1970s, when astronomers detected them as they blocked the light of a distant star. Now, as you float here, you can see them edge on, a faint striated structure encircling the planet. If you catch the sunlight at just the right angle, the rings glint ever so slightly, revealing themselves as a delicate lattice of dust and ice. Up close, the rings would appear as sparse collections of boulders and dust clumps, far less crowded than Saturn's icy hordes. The particles are coated with dark material, possibly organic compounds or radiation-darkened frost, which is why the rings reflect so little light and appear so shadowy. Still, they are a beautiful sight in their own quiet way, a series of gossamer loops encircling a sleeping cyan giant. Uranus also has a multitude of moons, at least 27 that we know of, each circling the planet in its equatorial plane, which is tipped on its side along with the planet. These moons bear whimsical names mostly drawn from the works of Shakespeare and Pope, adding a touch of literary romance to this distant realm. The two largest, Titania and Oberon, are sizable worlds over 1,500 kilometers across. Titania, named for the Queen of the Fairies, has a surface of cratered ice crisscrossed by enormous canyons, signs of ancient geological shifts. Oberon, named for the King of the Fairies, is a darker, heavily cratered globe, with mysterious black patches on some crater floors, where ice may have melted and refrozen. Closer to Uranus is Ariel, a relatively bright moon with young surface features, perhaps the most reflective of Uranus's big moons, showing evidence of past resurfacing by icy volcanism or tectonics. Umbriel, by contrast, is a brooding, dark sphere, the least reflective of the large moons, as if covered in charcoal dust, with just one bright ring-shaped crater, nicknamed the Fluorescent Cheerio, hinting at fresher ice beneath the gloom. Perhaps the most intriguing of Uranus's moons is little Miranda. Miranda is a small moon, only about 470 kilometers in diameter, yet it boasts one of the strangest landscapes in the solar system. It looks almost as though it was shattered and put back together in a jumble. As you draw nearer to Miranda, you see vast cliffs and patchwork regions unlike anywhere else. One area has giant chevron-shaped grooves and ridges. Another is lower and smoother, and yet another is heavily cratered. Miranda's surface seems composed of pieces with very different geologic histories. One of its scarps, Verona Rupes, plunges perhaps 20 kilometers, one of the tallest known cliffs in the solar system. If you stood at the top, the weak gravity means a stone would take a long, lazy fall to the bottom. Scientists speculate that Miranda might have been broken apart by a massive impact in the distant past and reassembled by gravity, or that internal forces caused the crust to fragment and refreeze in bizarre patterns. Whatever the cause, Miranda is a tiny moon that holds big mysteries on its scarred face, Drifting above Miranda's dramatically varied terrain, you can't help but feel wonder at how diverse and unexpected nature can be, even on a moon orbiting a distant, tilted planet. All these moons orbit Uranus along its tilted equator, so they too circle the planet like a set of rings turned on edge. From a vantage above Uranus's north pole, you would see the moons moving in nearly vertical orbits relative to the solar system's plane, tracing paths around Uranus's circumference. Occasionally, you might witness a moon casting a small shadow onto Uranus's cloud tops, or vanishing briefly as it passes into Uranus's shadow. Such events are subtle here, against the almost featureless backdrop of the planet. But they are happening quietly, a miniature celestial choreography governed by Uranus's gravity. Despite the observations we have made, Uranus remains a remote and enigmatic place. Only a single spacecraft from Earth, a brief visitor passing by in 1986, has ever scrutinized it up close. That lone flyby provided a glimpse of its moons and rings, but much of Uranus's story is still untold. As you float here now, you are witnessing a realm rarely seen in detail, one that humanity has only glimpsed in passing. The quiet emptiness around Uranus, the subtlety of its features, and the faint whisper of its rings all contribute to the feeling that this planet holds many secrets yet to be discovered. Still, the impression Uranus leaves on you is one of gentle calm and enduring patience. It rotates on its side in about 17 hours, carrying on its tilted dance through space as it has for billions of years. Its very uniqueness, the extreme tilt, the hush of its atmosphere, makes it a silent sentinel at this far-flung distance from the sun. As you finally bid farewell to Uranus, you do so with a sense of quiet admiration. In your mind's eye, the ghostly blue-green disk remains, a dim jewel marking the frontier of the giant planets. You carry with you the memory of Uranus's tranquil, sideways grace as you journey onward. Now, the path ahead leads you into even greater darkness and cold. Beyond Uranus lies the final major planet of our solar system, Neptune. Neptune is farther still, roughly another billion kilometers beyond, residing in the remote frontier of the Sun's domain. With one last backward glance at Uranus dwindling behind you, you turn and set your course for that next faint glimmer in the distance. Leaving Uranus behind, you venture onward into the silent depths of space, toward Neptune, the windy blue world awaiting at the edge of the solar system. The journey from Uranus to Neptune takes you through the farthest reaches yet. For billions of kilometers, you travel through emptiness, scarcely touched by sunlight. With each passing day, the sun grows ever fainter at your back, now just a particularly bright star among the countless others, offering only a ghost of warmth to these outer depths. You are truly venturing into the frontier of the solar system. Eventually, after a long voyage in the dark, a new presence greets you ahead. A dim blue point of light gradually brightens and enlarges. Neptune, the eighth and final major planet, is coming into view. As you draw closer, Neptune's color stands out, a rich, deep blue, more intense than Uranus's gentle hue. What was once a tiny speck becomes a small disk, and then a sizable globe before your eyes. Neptune emerges as a magnificent sapphire sphere hanging in the blackness. Its shade is a striking cobalt blue, reminiscent of the deepest oceans on Earth. This planet holds a special place in the history of discovery as well. Neptune was the first planet located through mathematics before it was directly seen. Astronomers in the 1840s noticed that Uranus's orbit was being perturbed by an unseen influence. By calculating where another planet should be, they pointed their telescopes and found Neptune in 1846, almost exactly where predicted. In honor of its ocean-like color, it was named Neptune after the Roman god of the sea, a nod to its blue appearance. Drawing nearer still, you begin to discern faint features in Neptune's atmosphere. The planet is banded by very subtle stripes of darker and lighter blue, much more muted than Jupiter's or Saturn's bands. High in Neptune's frigid atmosphere, thin, wispy white clouds streak the blue backdrop. These are methane ice clouds, propelled by fierce winds. Neptune's atmosphere is dynamic and surprisingly active, despite the weak sunlight here. Dark storm systems can form in its skies, though they are often short-lived. At one time, a huge storm dubbed the Great Dark Spot swirled in Neptune's southern hemisphere, about the size of Earth, but it vanished after a few years. Even now, new dark spots and bright white storms occasionally appear and fade, evidence of Neptune's ever-changing weather. What's truly astonishing are Neptune's winds, the fastest in the solar system. Jet streams on Neptune roar at more than 2,000 kilometers per hour, faster than the speed of sound. It's astonishing to witness such powerful winds in a place where sunlight is so scarce, suggesting that Neptune, like Jupiter and Saturn, has an internal source of heat fueling its weather. These fierce jet streams and storms drive the white methane clouds you see, causing them to zip around the planet. One particular kind of cloud, nicknamed scooters by astronomers, races around Neptune at high speeds, appearing and disappearing as it circulates the globe. From your vantage point, you see some of these slender white cloud streaks, casting tiny shadows on the lower cloud layers beneath. Evidence of the sun's light hitting them before the deeper layers. It is astonishing to think of such energetic weather in the dim outer reaches of the sun's influence. Neptune rotates about once every 16 hours. So as you watch, you can notice the movement of its atmosphere over time. A bright white cloud may traverse the face of Neptune in just a few hours. Before long, the region that was in daylight when you arrived drifts into darkness, and a new face of Neptune turns into view. On Neptune's night side, the darkness is nearly complete. With the sun so distant, night on Neptune would be an almost starlit blackness, relieved only by faint starlight and perhaps the ghostly flicker of auroras high above the poles, their light mostly in ultraviolet, invisible to human eyes. In Neptune's shadow, you would see the stars of the galaxy shine crystal clear around the planet's dark limb, while a silent cosmic light show might play out at the poles, hidden from normal sight. Encircling Neptune, you find a system of rings and moons, lesser known but fascinating all the same. Neptune has a collection of faint rings, made of dark dust and ice. They are tenuous and difficult to see, but as you align yourself with Neptune's equatorial plane and let the sunlight slant through, you begin to discern them. Neptune's rings are not uniform bands like Saturn's. They have curious clumps and arcs. The outermost ring, named Adams, contains several brighter segments, clumps of material that form partial arcs along the ring rather than a smooth spread. These arcs have poetic names like liberté, égalité, and fraternité, French for liberty, equality, and fraternity. For years, their existence was a mystery. Why didn't the material distribute evenly? It's now thought that gravitational tugs from Neptune's inner moons, confine these particles into arcs. To your eyes, the rings appear as dim, broken ribbons encircling the planet, only visible at all because of the angle of sunlight. They form a delicate, incomplete halo, as if Neptune wears a faded cosmic wreath rather than the bold garlands of Saturn. Still, there is a subtle beauty to them. They quietly accompany Neptune on its journey, whispering of a time long ago when a moon might have been shattered to create this dusty debris. Neptune's moons are numerous, 14 are known, but most are small and lie close to the planet. One moon, however, dominates the system. Triton. Triton is Neptune's largest moon and one of the most intriguing moons in the solar system. As you glide toward Triton, you notice something odd. Triton orbits Neptune in the opposite direction to Neptune's rotation, a retrograde orbit. This suggests Triton was likely captured by Neptune's gravity long ago, rather than forming alongside Neptune. Triton is about 2,700 kilometers across, comparable in size to our moon, and it's an extremely cold world. When you draw near Triton, you see a surface coated in ices, nitrogen ice, water ice, methane, and carbon dioxide ices, reflecting the feeble sunlight. Parts of Triton's surface have a slight pinkish tint, likely due to complex organic molecules formed by solar radiation interacting with methane ice, painting the landscape with a faint blush. The terrain of Triton is otherworldly. Some regions are smooth plains of frozen nitrogen, while others are etched with strange circular depressions and pits, like the skin of a cantaloupe melon. There are ridges and troughs, and large swaths that seem almost unfinished, as though remade by internal processes. Triton has a very thin atmosphere, mostly nitrogen with a trace of methane, which is just enough to support weather phenomena like thin clouds or hazes. As the weak sunlight hits Triton's polar ice caps, something remarkable occurs. Geysers erupt. You might witness, against the starry sky, dark, feather-like plumes rising from Triton's sunlit southern polar region. These geysers are driven by the slight warmth of the sun. A transparent layer of frozen nitrogen on the surface warms just enough underneath to vaporize some of the ice. Pressure builds, and then the gas bursts out through cracks, carrying dark particles of dust with it. The plumes jet upwards several kilometers before arcing in the gentle gravity and drifting back down, the particles settling onto the surface as dark streaks. It's a breathtaking sight, yet it unfolds in near silence and slow motion. In Triton's feeble gravity, about 1/14 that of Earth, these geyser particles waft slowly, blown by a faint breeze as they fall. You watch one of these nitrogen geysers, a ghostly fountain of gas and dust, silently billowing upward and then gently curving back toward the ground. It is perhaps the quietest volcanic eruption imaginable, more like a soft exhalation of the moon than a violent blast. Now imagine standing on Triton's frozen surface. The ground is solid ice. Water ice as hard as rock and nitrogen ice coating it in places like a frosty glaze. The temperature is nearly 240 degrees Celsius, and the thin atmosphere offers no protection. The sky is a dim blue-grey, and the sun is a tiny distant point of light, providing only a dusky glow. Over the horizon, Neptune looms enormous in the sky, a great blue-green disk banded with clouds. If it is daytime on Triton, Neptune might be visible as a huge pale blue shape hanging low, perhaps with a thin crescent of sunlight along one edge. If it is nighttime, Neptune appears as a vast silhouette against the starfield, maybe edged with a faint glow of its own thin rings. The stars themselves are brilliant an untwinkling in Triton's airless sky. Nearby, a dark plume from a geyser rises slowly, almost gently, into the sky, and you might see the faint pink hue of Triton's surface where those plume deposits have fallen. The silence is absolute. No sound of wind, just the crunch of frozen nitrogen underfoot if you move. You feel an immense loneliness, but also a profound serenity, standing on this moon at the edge of the sun's reach. Leaving Triton, you cast your eyes on a few of Neptune's other moons as you depart. There is Nereid, a tiny moon that follows a distant, eccentric orbit, coming and going far from Neptune. There is Proteus, a dark and irregularly shaped moon that orbits closer in, so dark that it nearly disappears against space. These moons, and several others, small and lumpy, circle Neptune as captured wanderers or fragments of long-ago collisions. They each have their own stories, but they appear only as faint, star-like dots as you glide away from Neptune. Having explored the Neptune system, you prepare to venture beyond the last planet. Neptune, the beautiful windy blue giant, slowly recedes behind you. Its deep azure glow fades, and its faint rings and retinue of moons merge back into the darkness. You take with you a memory of Neptune's serene blue colour and Triton's silent geysers, impressions of a distant, frozen wonderland at the edge of the planetary realm. Out at Neptune's distance, roughly 4.5 billion kilometres from the Sun, so far that sunlight takes over 4 hours to reach this spot. The Sun has dwindled to just another bright star in the sky. Its feeble light scarcely outshines the background glow of the Milky Way. The night sky around you is rich with stars. With the Sun's glare so diminished, you can see the Milky Way's faint band of light clearly, a river of countless distant stars arching across the blackness. The cosmos here feels especially close and breathtaking, a sparkling tapestry of the galaxy spread behind Neptune's fading silhouette. The silence and darkness are profound, yet the soft luminance of far-off suns provides a gentle, eternal backdrop. Now you turn your gaze outward once more, toward the vast unknown that lies beyond Neptune. Out here, beyond the planets, the solar system continues in a different form, a realm of small icy bodies and distant wanderers. The Kuiper Belt awaits, a broad expanse filled with ancient frozen remnants of the solar system's formation. In that distant domain, Pluto circles the Sun, along with other dwarf planets such as Eris, Haumea, and Makemake, and countless smaller icy worlds. These frigid dwarfs are like miniature planets, many with their own moons, all bathed in perpetual twilight as they orbit in the far cold. Farther beyond even that, an invisible sphere of comets known as the Oort cloud is thought to surround the solar system, extending perhaps a quarter of the distance to the nearest stars. In these outer reaches, the Sun's influence grows faint, and the boundary between our solar system and the wider galaxy begins to blur. Though Neptune is the last of the classical planets, your journey is far from over. There are more distant wonders to encounter in the darkness beyond. With one last backward glance at the tiny blue dot of Neptune, you set your course for the mysteries that lie ahead. The spacecraft of your imagination, or perhaps simply your point of view, moves ever outward into the cold beyond Neptune, where new discoveries await. The quiet, starlit road ahead promises awe-inspiring sights in the dark frontier beyond the planets. The voyage through the solar system carries on, gently drawing you deeper into the endless night. The journey continues as you drift onward into the cosmic darkness, toward whatever wonders may come next. Saturn's shining rings slowly fade into the darkness behind us, their glimmering bands of ice and dust becoming faint silvery threads until they vanish from view. As we bid farewell to Saturn, we look back for a moment. The once grand rings are now just a faint glimmer encircling a tiny golden point of light. Beyond that speck, closer to the sun, lie the inner planets we left long ago, but they are far out of sight now. Ahead of us, only the outer darkness beckons. We drift onward into the silent abyss, leaving behind the golden planet and its swirling clouds. Out here, far beyond the bright heart of the solar system, starlight surrounds us. The sun itself has grown smaller and gentler, a distant star shining quietly, offering just a pale glow to light our path. For a long while, we travel through deep space, in no hurry at all, enveloped by a profound calm. The darkness is vast, but not empty. The faint haze of distant stars paints a delicate backdrop, and now and then a lonely comet or dust grain crosses our course. As the hours pass in tranquility, a new pinprick of aquamarine light begins to brighten ahead. Gradually, it resolves into a pale blue-green orb suspended in the blackness. Our next destination has revealed itself. We are approaching Uranus, the first of the ice giants, a mysterious world tipped on its side and wrapped in a cloak of azure haze. Out here, nearly 3 billion kilometers from the sun, the sunlight is but a pale ghost of what we know on Earth, roughly 400 times fainter. The sun in Uranus's sky looks like a brilliant star, not blindingly bright as it appears from the inner solar system, but still the primary light in the darkness. Even so, it is enough to lend Uranus its gentle glow. From a vantage point high above Uranus's north pole, we watch as the planet slowly rotates. It completes one turn about every 17 hours, spinning around that tilted axis. As it rotates, we notice that the sun's rays cover the polar region continuously. The pole basking in sunlight is encircled by a bright haze, while the rest of the planet's disk gradually fades into the soft twilight at the terminator. To better appreciate Uranus's strange orientation, we adjust our position and fly along its equatorial plane. Now the planet's rings and moons appear to circle it from top to bottom rather than side to side, due to the extreme tilt. It's as if Uranus were a rolling ball and its rings a wheel turned on its side, spinning upright around the planet. This unusual geometry gives Uranus a unique kind of grace, unlike any other planet we have seen. Uranus drifts in lonely majesty in the far reaches of the solar system. This distant world glows a gentle blue-green, like a turquoise marble set against the starry curtain of space. Its hue is the result of methane gas in the upper atmosphere, which absorbs the warm colours of sunlight and leaves only a cool cyan light to be reflected back. As we draw closer, the planet's unusual orientation becomes apparent. Uranus is tipped on its side, rotating almost horizontally as it circles the sun. Long ago, a colossal collision or cosmic event may have knocked it askew, leaving it tilted over by nearly 90 degrees. Because of this, Uranus rolls around the sun like a sleepy ball, with its poles taking turns facing the sunlight. For about 42 years at a time, half of its long year, one pole basks in continuous daylight, while the other is submerged in unbroken night. Then, slowly, dawn comes for the winter pole as the seasons change and the opposite pole begins its decades of darkness. We drift over Uranus's sunlit pole, gazing down at a bright cap of haze illuminated by the distant sun. Below us, the atmosphere is a placid pastel blue, seemingly featureless and calm. In visible light, Uranus's face looks smooth and unblemished, a tranquil-looking sphere, with barely any cloud bands or storms to mar its appearance. But beneath that serene facade, powerful winds are blowing. High-altitude clouds and subtle bands can be seen if we enhance our view. Delicate swirls of white methane ice crystals and faint grey streaks where fast winds, some reaching hundreds of kilometers per hour, encircle the planet. Despite being far from the sun's warmth, Uranus's atmosphere still stirs and shifts, though gently compared to its more boisterous neighbours. The temperature here sinks lower than on any other planet, plunging hundreds of degrees below zero, a testament to how remote Uranus is from the sun's heat. Yet, deep inside, this ice giant may have a warm heart, a small rocky core generating a bit of heat, surrounded by dense, hot fluids of water, methane, and ammonia hidden far below the clouds. That internal warmth is faint, but perhaps enough to drive the subtle weather we see. Encircling Uranus are several thin rings, far more subtle than the famous rings of Saturn. In passing, we align with Uranus's equator to examine these rings. They appear as dim, narrow hoops of dust and ice that barely catch the sunlight at this great distance. In the weak blue glow reflected from the planet, we can just make out a few faint arcs shimmering like ghostly bands. Fine grains of dark material comprise them, leftover debris shepherded by Uranus's tiny moons. Starlight can be seen through the gaps, giving the rings an almost transparent quality. They form a delicate halo around Uranus, held in place by the gravity of small shepherd moons that weave through the rings and keep them from dispersing. Indeed, beyond the rings lies a retinue of moons, more than 24 icy companions orbiting the tilted planet. Each moon is unique, a silent world unto itself. One of the most peculiar is Miranda, a smaller moon with one of the strangest landscapes in the solar system. As an experiment of imagination, we descend briefly to Miranda's surface. The gravity is weak, less than 1% of Earth's, and our steps are slow bounds over the frozen ground. When we look up, we are met with an awe-inspiring sight. Uranus fills a huge portion of the sky, a massive blue-green ball looming overhead. The planet's rings encircle it as a thin, bright line, arcing across the sky like a cosmic rainbow. No atmosphere disturbs the view. Uranus hangs there silently, banded with subtle tones. The sun's light is dim here, but it illuminates Uranus enough for us to discern wispy clouds on its disk. Around us, Miranda's bizarre landscape of jagged cliffs and troughs lies in deep shadow, except where sunlight reflects off Uranus and faintly brightens the icy rocks. In this alien sky, one could almost imagine reaching out and touching Uranus's swirling clouds, so close they seem. We take in this otherworldly panorama for a moment, then gently lift off back into space, carrying the memory of that sky view with us. One of the most peculiar moons indeed is Miranda. As we glide past this moon again, now from orbit, we see huge canyons and cliffs ripping across its surface, some nearly 20 kilometers deep. Its patchwork terrain looks as though ancient forces tore it apart and pieced it back together in haphazard fashion. Yet even these gigantic scars lie frozen in stillness, unchanged for untold eons, illuminated softly by the distant sun. Not far from Miranda, Ariel and Umbriel circle as sibling moons, Ariel's bright ice canyons shining here and there, while Umbriel lurks darker, its surface like charcoal peppered with craters. Further out, Titania and Oberon, the largest of Uranus's moons, move in wider orbits. Named after magical fairies of old, they are spheres of rock and ice, their ancient cratered surfaces quietly reflecting the faint sunlight. On Titania, long chasms scar the crust, perhaps remnants of an internal ocean that froze and expanded, cracking the surface. Oberon, the outermost major moon, is mottled with mysterious dark patches on some crater floors, like ink blots on grey ice, hinting at unknown materials or processes. All these moons dance around Uranus's equator, which is tilted steeply relative to its path around the Sun. The entire system of rings and moons is tipped sideways along with the planet, like a cosmic mobile knocked askew. We drift above this unusual arrangement, marveling at how quietly it has persisted in its sideways dance through space. In the silence, Uranus and its family of moons cast a serene tableau, a world turned on its side, yet continuing steadily on its remote orbit, unfazed by its odd orientation. We linger for a moment, contemplating this tipped world. In its quiet orbit, Uranus keeps its mysteries to itself. Our brief visit has shown us only a placid blue mask hiding unknown depths. With a last, wistful glance at its pale disk, we carry onward, wondering what secrets might lie beneath those hazy clouds. Now, as we leave Uranus behind, we look ahead once more, toward the outermost of the giant planets. Far beyond Uranus, another blue world awaits, darker, more distant, yet beckoning us onward. The journey from Uranus to Neptune spans another vast gulf of space. For years we drift through an almost featureless void. Occasionally, we pass the orbit of a tiny ice chunk or catch a glimpse of a distant star cluster. But mostly, it is the deep black of interplanetary space that surrounds us. As Neptune's gravity gradually begins to tug on our spacecraft, the Sun has diminished to roughly 1/900th of the brightness it has at Earth. We are truly far from home, in a realm that was entirely unknown to ancient skywatchers. Slowly, the speck of Neptune grows from a dot to a disk, heralding our approach to the solar system's final planet. Neptune emerges from the darkness as a profound, deep blue orb, the colour of a tranquil twilight ocean. It is named for the Roman god of the sea, an apt name for such a blue world. Being roughly the same size as Uranus, Neptune is another ice giant, but its appearance and character are distinct. Where Uranus was a gentle cyan and placid, Neptune is a richer cobalt blue and more visibly dynamic. From afar we can already sense its restless atmosphere. This remote planet, 30 times farther from the Sun than Earth, surprisingly harbours some of the fastest winds in the solar system. As we approach, we notice subtle bands and whirling storms in the blue cloud tops. Once, a large oval storm called the Great Dark Spot was seen swirling in Neptune's southern hemisphere. A tempest as wide as the Earth that came and went, leaving behind only calmer skies when it vanished. Neptune's atmosphere is cold and thin at the top, but the planet emits an internal warmth that stirs up weather far more active than on Uranus. White clouds of methane ice scud swiftly around the globe, driven by winds that can reach over 1,000 kilometers per hour. Despite the ferocity of these gales, all is silent in the vacuum of space where we drift. And from here, Neptune's storms seem like slow, graceful swirls of paint in a cosmic ocean. Yet beneath Neptune's turquoise haze, even stranger things may occur. Deep inside, where the pressure and temperature soar, ordinary compounds take on exotic forms. Methane in Neptune's inner layers could break apart, the carbon compressing into crystals of diamond that rain down through the dense interior. Imagine glittering fragments falling silently for thousands of kilometers in the darkness, forming layers of diamond hail around the planet's core. This is a theoretical vision hidden far below Neptune's cloud tops. If it happens at all, it is concealed under crushing pressures we can scarcely imagine. From our distant viewpoint above, we see none of this directly, but the very idea adds to Neptune's mystique. We pass over Neptune's day side, looking down at an endless expanse of azure atmosphere. There are lighter stripes and dimmer bands circling the planet, hints of belts and zones created by atmospheric currents. Toward the terminator, the gradual line between day and night, the blue fades into a deep indigo, and then black as Neptune's night side lies in frigid darkness until the sun rises again. Neptune has a delicate system of rings as well, though much fainter than Saturn's or even Uranus's. These thin arcs of dust and ice encircle the planet in several broken rings that are clumpy and incomplete. In some places, the rings form brighter segments, denser patches that shine a bit more clearly, while elsewhere they all but disappear, as though the ring were only a partial halo. We align our trajectory with Neptune's equatorial plane to examine these tenuous rings. They appear as dim, patchy arcs, more suggestion than substance, illuminated only when the angle is just right. Fine particles of ice and dust comprise them, likely corralled by the gravity of little moons. The rings have gaps where starlight filters through freely, giving them an almost transparent quality. Unlike Saturn's broad, glittering rings, Neptune's rings are ghostly and fragmentary, but they still encircle their planet as if marking its territory in the dark. Neptune is attended by a whole family of moons, at least 14 known satellites, mostly small and shrouded in darkness. One of them, a moon named Proteus, is so dark and so close to Neptune that it blends into the night. It wasn't discovered until a spacecraft, Voyager 2, visited Neptune for the first time in 1989. Proteus is irregular in shape and pocked with craters, an ancient piece of Neptune's retinue that has seen little sunlight. Another tiny moon, Nereid, wanders in an elongated orbit far from the planet, carrying it on a lonely journey into distant space and back again each Neptune year. But dominating them all is Neptune's largest moon, Triton, a world so intriguing that it draws our attention as we glide nearer. Triton is not just a moon. It is a frigid world with its own atmosphere and geology, a captured wanderer that now accompanies Neptune. As we draw close to Triton, we see it illuminated by the distant sun and by the reflected blue light from Neptune. The moon's surface is a mosaic of pale pinkish white and darker regions, an icy crust sculpted by processes unlike any on Earth. Triton orbits Neptune in the opposite direction of Neptune's rotation, a retrograde motion, hinting that Triton likely originated elsewhere and was snared by Neptune's gravity long ago. In the aftermath of that capture, Triton's orbit became locked in synchronous rotation. So one face of Triton now perpetually gazes at Neptune. If we hover above Triton's Neptune-facing hemisphere, we would see the giant planet hanging in the sky, a massive blue-green disk dominating the horizon. Triton's gravity holds us gently to its surface as we imagine standing on this distant moon. The sky here is dim, The sun is no more than a brilliant star low in the sky, providing feeble light and little warmth. A thin atmosphere of nitrogen envelops Triton, so tenuous that it would be almost unnoticeable to us, yet thick enough to have winds and thin clouds of its own. In the faint daylight, we witness a rare and wondrous sight, dark geysers slowly erupting from Triton's icy plains. These are cryovolcanoes, not of hot water or lava, but of cold nitrogen gas carrying dark particles. Warmed slightly by sunlight, pockets of frozen nitrogen beneath the surface turn to gas and burst out, spraying dust and gas upward. We see a delicate plume rising several kilometers high, then drifting gently in the weak breeze, casting a thin shadow on the ground before the material falls back to the surface like fine dark snow. Along Triton's terrain, we notice areas that look oddly textured and dimpled, nicknamed cantaloupe terrain for their resemblance to a melon's skin. These swells and depressions may have formed as the crust was slowly deformed by the freezing and refreezing of subsurface ices, or by ancient geological upheavals. Elsewhere, parts of Triton's surface appear smooth and young, possibly resurfaced by past cryovolcanic flows that covered old craters with fresh frost. Despite the occasional geologic activity, an immense silence pervades this moon. The only sounds would be the whisper of a frigid wind and the faint hiss of distant geysers, too gentle to carry far in the thin air. Overhead, Neptune remains fixed in the sky, its immense presence casting a deep blue glow on Triton's icy ground. In the far distance, beyond Neptune, the stars crowd the sky, and somewhere out there lies the realm from which Triton may have come. Triton's quiet geysers and strange patchwork terrain linger in our minds. This captured moon, with its thin sky and active ice volcanoes, feels like a final outpost of geologic life in the solar system's far corner. As we prepare to depart Neptune's domain, we take with us a sense of awe at its dynamic nature. This remote giant, though seemingly serene from afar, harbours fierce winds and perhaps showers of diamonds in its hidden layers. It is a planet of contrasts, calm blue on the outside, restless and wild within. Neptune reminds us that even in the far reaches of the sun's realm, there is energy and motion, a living weather that never ceases. Having marvelled at Triton's mysterious beauty, we gently ascend once more, leaving Neptune's kingdom. We take a final look back, Neptune's deep sapphire sphere, and Triton's pale, scarred globe beside it slowly recede, their bond a lonely partnership at the edge of the planetary system. Beyond Neptune, the solar system stretches out into an even deeper frost. Here, the darkness is nearly complete, with the sun only a small, star-like disk far behind us. For a long while, we see little more than the endless void scattered with stars. But gradually, as we continue outward, we begin to encounter a new region of space filled with ancient, frozen remnants. We have entered the Kuiper Belt, a distant ring of icy bodies encircling the sun beyond the planets. Unlike the inner asteroid belt of rock and metal, this outer belt is composed of primordial ice and dust left over from the formation of the solar system. Countless objects, some as small as pebbles, others hundreds of kilometers across, wander in this cold twilight, orbiting the sun in slow, slanted paths. The Kuiper Belt is vast and diffuse. Its members are spread across a great expanse, separated by millions of kilometers of emptiness. Occasionally, as we drift, we catch sight of a glimmer, a distant ice-coated rock reflecting a feeble ray of sunlight, a tiny worldlet that has never felt the touch of warmth. As our eyes adjust to the starlight, one such glimmer grows brighter than the rest. It resolves into a little globe shining with a muted beige and white hue against the black background. This is Pluto, once deemed the 9th planet, now recognized as one of the largest of the Kuiper Belt's dwarf planets, and one of the most fascinating. As we draw nearer to Pluto, details on its surface begin to emerge. Although only about 2/3 the diameter of Earth's moon, Pluto's landscape is surprisingly varied and complex. We see bright and dark patches spread across its surface like the markings of an unevenly frosted glass ball. Most striking is a large, bright region shaped uncannily like a heart. This heart-shaped feature, called Tombor Regio, spans a vast area on Pluto's surface. Half of it is an enormous plain of smooth, light-coloured ice, a feature named Sputnik Planitia. Sputnik Planitia is composed primarily of frozen nitrogen. No impact craters mar this plain, indicating it is geologically young and active, constantly renewed by processes beneath. Indeed, its surface is divided into gentle polygonal cells, hinting at convection currents slowly cycling the ice over millions of years. Along the edges of this plain rise Pluto's great mountains. These peaks are made of water ice that is as hard as rock at Pluto's frigid temperatures. Some mountains soar 3 or 4 kilometers high, their ridges capped with blankets of methane snow that gleam softly in the sunlight. Around Pluto's equator, and on the opposite side of the heart, we see broad swaths of darker terrain. These areas have a ruddy, brownish hue, likely due to complex organic molecules called tholins that form when the faint sunlight interacts with methane on the surface. They paint Pluto's surface with dusky shades, giving it a mottled, earthy appearance in places. Toward Pluto's poles, the coloration and brightness change with the seasons. When a pole is in continuous sunlight for decades, its surface ices slowly sublimate into the atmosphere, leaving behind darker, unfrosted ground. When that pole plunges into the decades-long winter darkness, the atmosphere there condenses and snows back down, coating the polar region in fresh, bright frost. Pluto's surface temperature is extraordinarily low, around -230 degrees Celsius on average, cold enough that most gases like nitrogen and methane remain frozen solid. Still, during its 248-year orbit, when Pluto comes closest to the Sun, a portion of these ices warms slightly and turns into gas, forming a thin atmosphere around the planet. As we watch from our vantage, we notice a tenuous haze above Pluto's limb, a faint envelope of atmosphere extending upward. When the geometry is just right, with the Sun behind Pluto, this atmosphere becomes visible as a delicate blue halo encircling the dwarf planet. It is as if Pluto wears a glowing veil during sunrise and sunset, a band of twilight that rings its entire globe. In the daytime on Pluto, the sky would still be mostly black, but near the horizon you might see that slight blue tint from the haze. The Sun, though distant and weak, still brings a pale daylight to Pluto, comparable to an early evening on Earth. Stars would be visible even at noon, pricking through the dim sky, since the sunlight is never strong enough here to wash them out. Standing on Pluto's surface during daytime would feel like standing in perpetual twilight. Now, imagine for a moment we could descend to Pluto's surface near the edge of its great ice plain. We stand upon frozen ground at the boundary of the bright heart region and the darker highlands. The Sun is low on the horizon, casting long, faint shadows from the craggy mountains of ice behind us. The landscape is quiet and still. Beneath our feet, the ground is solid nitrogen ice with a dusting of methane snow, smooth in some places and lightly textured with the geometric patterns of slow upwelling and sinking ice. In the distance, jagged peaks of water ice rise, their slopes tinted faintly blue-grey, illuminated by the slanting sunlight. In the sky above, a magnificent sight greets us. Pluto's largest moon, Charon, hangs motionless, locked in the same spot in the heavens. Charon appears huge from Pluto's surface, covering a sizable portion of the sky. Its colour is a muted grey, with a tawny reddish cap at its north pole, a stain left by gases escaping from Pluto and freezing onto Charon's surface. The rest of Charon is scarred with craters and cut by deep chasms. A vast canyon system snakes across part of Charon, evidence of past geologic activity that cracked its crust as an underground ocean may have frozen long ago. But at this tranquil moment, Charon is simply a silent, looming companion in the dark sky, forever facing the same side toward Pluto. As the sun sets, Charon's grey face catches the last rays of light, and an otherworldly twilight envelops Pluto. The distant sun slips below the horizon, and a soft darkness falls. Above, Charon remains visible as a large, dim disk, now lit faintly by the ghostly glow of sunlight reflecting off Pluto's own surface. A gentle illumination in the Plutonian night, much as our moon lights the night on Earth. All around, countless stars pierce the darkness, and the band of the Milky Way glitters across the sky, unmarred by any atmosphere. In this profound night on Pluto, one feels a sense of ancient solitude and peace. In the gentle twilight of Pluto's realm, we sense an almost spiritual calm. Here, nearly 4 billion miles from the sun, this little world has a character all its own, tranquil, mysterious, and quietly enduring. Pluto's bright heart and its steadfast moon. Charon feel like a cosmic Valentine at the edge of the solar system, an unexpected touch of warmth in the cold. Our time here has shown that even at the sun's frontier, there are marvels. Blue hazes, icy mountains, and active glaciers of exotic ice slowly renewing the surface. Reluctantly, we must leave this distant wonder behind. We take a step back, lifting off from Pluto's surface in our mind's eye, to continue our journey outward. As we depart Pluto's realm, we take note of the smaller companions and distant cousins that populate this outer frontier. Apart from Charon, Pluto is attended by 4 tiny moons: Styx, Nix, Kerberos, and Hydra. These minuscule companions, each only a few tens of kilometers across, orbit the Pluto-Charon pair in eccentric paths. They are like chips of ice dancing around the 2 larger bodies, tumbling end over end as they go. In the dim sunlight, these little moons gleam faintly, their irregular shapes reflecting a flicker of light as they spin. Leaving Pluto and its moons behind, we gaze outward into the far stretches of the Kuiper Belt. Pluto, as remarkable as it is not unique out here. It is one of several known dwarf planets inhabiting this distant zone. Farther from the Sun than Pluto, on an even more elongated path, lies Eris. Eris is nearly the same size as Pluto and even more massive, making it the most massive dwarf planet discovered so far. Its surface is extremely reflective, cloaked in a frozen atmosphere of methane that gleams in the feeble sunlight. Eris follows a stretched orbit that carries it much farther from the Sun at times than Pluto ever goes. It has a tiny moon of its own, named Dysnomia, quietly circling it in the far cold. Another distant world is Haumea, an egg-shaped dwarf planet that spins so rapidly on its axis, one rotation every 4 hours, that its body has been stretched into an elongated shape. Haumea's rapid spin has endowed it with a ring of particles and 2 small moons, making it a truly exotic member of this distant collection of worlds. Its surface is bright and icy, and it gleams with a crystalline sheen due to resurfacing from past impacts. Makemake is yet another, slightly smaller than Pluto, with a reddish, methane-rich surface. Makemake is one of the brighter objects in the Kuiper belt and has at least 1 moon of its own. These dwarf planets, along with others yet to be discovered, form a family of icy mini-worlds encircling the Sun from afar. Each holds clues about the early solar system, preserved in their distant, frozen havens. The outer solar system remains the least explored and most mysterious part of our cosmic neighborhood. As we gaze into the black beyond Pluto, we realize there may be many worlds yet undiscovered, quietly circling in the dark. A faint tug on a distant orbit, a subtle shadow on a star. These are the only hints of the unseen. It sparks our imagination. Perhaps a hidden planet wanders out there, or a multitude of Pluto-like bodies still awaiting discovery. In this silent expanse, the boundary between what we know and what we have yet to learn blurs. We carry this sense of mystery with us as we push further out. Occasionally, 2 of these distant bodies may drift near one another, or a tiny Kuiper belt object might get caught by a giant planet's gravity and flung into a new orbit. Occasionally, their orbits are nudged by subtle gravitational influences we do not yet fully understand. Some scientists theorize that an undiscovered planet, often nicknamed Planet 9, could be lurking far beyond Neptune. Its gravity might be shepherding some distant orbits into the peculiar clusters we observe. If it exists, this hidden giant would lie hundreds of billions of kilometers away, taking tens of thousands of years to complete one orbit around the Sun. For now, Planet 9 remains purely hypothetical, a tantalizing mystery that adds to the allure of these distant reaches. Out here, the Sun's pull is weak, but it still governs the motions of these far-flung objects. One such distant wanderer, named Sedna, moves on a particularly remote path. Sedna's orbit is so elongated that it takes over 10,000 years to complete a single circuit around the Sun. At its farthest, it ventures into the very edges of the Sun's domain, nearly 1/5 of the distance to the nearest star. At that remote aphelion, the Sun is merely a particularly bright star in Sedna's sky, and the cold on Sedna's surface is beyond anything we can truly imagine. Sedna's existence hints at a vast collection of still undiscovered bodies in the extreme outer solar system, transitional between the Kuiper belt and the truly distant Oort cloud. Now we venture into the farthest outskirts of the Sun's influence, the realm of the Oort cloud. Here, at last, is the boundary of the solar system's icy empire, far beyond the structured orbits of the planets and Kuiper belt objects. The Oort cloud is thought to form a vast spherical shell of comets encircling the Sun. We are tens of thousands of times farther from the Sun than Earth is. We are on the scale of light years now. The Sun's light has dwindled to a feeble gleam, and the warmth we once felt is nearly gone. Out here float trillions of frozen bodies, the nuclei of comets, like a distant swarm of hibernating snowballs. They are spread so far apart that one could travel for weeks or months and not encounter another. The Oort cloud itself is invisible to us. Its comets are too small and sparsely distributed to catch our eye. But we know this realm exists by the occasional comets that fall inward toward the sun. Each long-period comet that graces the inner solar system with a glowing tail is a traveller that likely originated from this distant reservoir. Disturbed perhaps by a passing star or the tidal forces of the Milky Way, a comet begins a slow, centuries-long fall toward the sun. For millennia, it travels in the darkness, eventually entering the inner solar system, where the sun's heat causes it to sprout a beautiful tail visible even from Earth. Such long-period comets, arriving from random directions after thousands of years, are visitors from this remote province of our solar system. Each of these frozen wanderers is like a time capsule from the solar system's youth, preserving the primitive building blocks of planets and perhaps the seeds of life in deep freeze. In the Oort cloud, time stretches into epochs and change is nearly imperceptible. A comet might spend eons in deep freeze here until a subtle gravitational nudge sends it on a new path. At these distances, the sun's gravitational hold is incredibly weak, just enough to keep these cometary ice balls bound in a loose cloud. Beyond this, the gentle tug of other stars and the tidal pull of the galaxy begin to influence them. In fact, we are now about a quarter of the way to the nearest star. Beyond the Oort cloud, interstellar space truly begins. Even before we exit this comet cloud, another invisible frontier has already been crossed. Many billions of kilometers ago, we passed through the edge of the heliosphere, the vast bubble of solar wind that envelops the planets. Within the heliosphere, the sun's energetic particles stream outward, pushing against the thin gas that drifts between the stars. But eventually, around 18 billion kilometers from the sun, that solar wind pressure faded to a stop, merging with the interstellar medium. At that boundary, the heliopause, the protective bubble of our solar system, ends, and we entered the realm of the galaxy. Out here, cosmic rays and stray atoms from other stars roam freely, no longer held at bay by the sun's influence. A pair of human-made envoys have experienced this transition firsthand, the Voyager 1 and Voyager 2 spacecraft. Both launched in 1977, these robotic explorers journeyed through the planetary realm and then continued ever outward. By 2012, Voyager 1 had crossed the heliopause, followed by Voyager 2 in 2018, becoming the first objects from Earth to enter interstellar space. Now, Voyager 1 is over 23 billion kilometers, about 14 billion miles, from the Sun, and Voyager 2 is not far behind. They are far beyond Pluto's orbit, in the darkness between the stars. Though their power is fading, they still send back whispers of data, telling us about this new frontier. Each carries a golden record, a message in a bottle for any future finder, containing sounds and images of Earth, a friendly greeting from our world cast into the cosmic ocean. They are our lonely ambassadors, bearing a greeting from humanity into the great unknown. Soon, within a few years, their power sources will be exhausted and they will fall silent. Yet they will continue coasting outward, forever bound toward the center of our galaxy, perhaps to wander for millions of years among the stars. In about 40,000 years, Voyager 1 will drift within a couple of light years of another star, faintly joining the stars it once observed from afar. There is something profoundly moving about these tiny travelers, forging ahead through eternal night. As we accompany these voyagers in our thoughts, we look back one last time toward our sun. It is nearly indistinguishable from the countless other stars around us. From here, nearly a light year away, the sun appears as just another star, still the brightest in our sky, but no longer a dominant light. The planets we visited, The gas giants, the icy moons, the dwarf planets, now lie too close to the brilliant sun to pick out individually, or are too faint and small to be seen at all. Perhaps, with a powerful telescope, we might barely discern Jupiter or the glint of Saturn's rings. Earth, at this distance, is lost in the sun's glare, a mere mote of blue dust against the vastness. And so, at this great distance, we have reached the outer limits of our solar system. Our journey from the sun's fiery heart to the cold cosmic shore is complete. We have floated through the majestic rings of Saturn, skimmed the azure clouds of Uranus and Neptune, walked the icy plains of Pluto, and traversed the endless night of the Oort cloud. In all that vastness, we found beauty and tranquility in equal measure. Each world, each ring, each moon and comet moves in silent harmony, bound by the gentle pull of our star. Though the solar system is immense, it is also a place of order and rhythm, a celestial dance that has carried on for billions of years and will continue for billions more. As we reflect, we recall how these remote wanderers were named after gods and mythical beings by those who first tracked their faint lights in the sky. Now we have seen them up close, and each indeed possesses a godlike splendor in its own way. As we pause here on the threshold between our solar system and the wider galaxy, we feel a deep peace. The darkness is not empty or frightening, for it is filled with the steady light of distant stars and the quiet assurance that the sun's family of planets is still out there, spinning calmly in the void. Our own Earth is among them, a pale blue gem cradled in sunlight, home to everything and everyone we hold dear. Knowing this, we are comforted. We have seen how the cosmos, despite its grandeur, operates with a gentle continuity. The planets will continue to trace their orbits, comets will slumber in their distant cloud until they are called inward, and our sun will keep shining, faithfully marking the days and seasons. We too are a part of this cosmic tapestry, connected to all the worlds and the star that we've journeyed past. Here, at the edge of the solar system, under the eternal night sky, we let the silence and wonder wash over us. Our voyage has been vast and astonishing, yet it has also been calm and dreamlike. Now, it is time to drift gently back from this great expanse. In the quiet of the night, under the same stars that glitter above Pluto and beyond, we allow ourselves to rest. The cosmic dance carries on overhead, faithful and unhurried. We are safe, and we are at peace, cradled by the universe that made us. As the starlight falls around us, we close our eyes and let the vastness of space lull us into a deep and restful sleep, our hearts filled with the tranquil beauty of this journey among the worlds. Beyond the orbit of Mars, we enter a vast expanse filled with remnants of creation. Here drifts the asteroid belt, a broad band of countless rocks and debris left over from the solar system's birth. In this gentle darkness between worlds, silent stones float in solitude. Some are no larger than pebbles, while others are hundreds of kilometers wide. These are ancient time capsules, fragments of the primordial cloud that failed to become a planet, now circling the sun in quiet procession. In fact, it may have been the influence of Jupiter's strong gravity that prevented these pieces from gathering into one world. Instead, Jupiter's tug kept them stirred and scattered, ensuring they remained as fragments. As we glide through this cosmic shoal, imagine the scene. Sunlight filtering through the void, touching the pitted surfaces of these tumbling rocks. They have hung here for billions of years, largely unchanged. Occasionally, two asteroids cross paths and collide, a slow-motion dance of destruction that sends out smaller fragments. Over ages, gravitational nudges from the giant planets can disturb an asteroid's path, flinging it inward toward the Sun. Most will simply continue their endless orbit, but a few may set course for the inner solar system, some even toward Earth. Imagine for a moment standing on one of these drifting asteroids. The ground beneath your feet is grey and powdery, littered with small craters and broken stones. The gravity is so weak that each step feels slow and shuffling, and a strong jump could send you gently floating. The horizon curves sharply just a short distance away, as if you stood on a tiny hillock in space. Above you, the sky is utterly black, spangled with unblinking stars. The sun, though distant, is a fierce point of light that casts sharp shadows. There is no air, no sound, only a profound silence. If you were to pick up a pebble and toss it, it might sail off and never return, escaping the asteroid's feeble hold. In this stillness, time has little meaning. A boulder could lie undisturbed for 1,000,000 years, until one day a far-off gravitational tug nudges the asteroid on a new path, or a micrometeorite's tiny impact sends a few grains of dust floating off. Asteroids have visited Earth many times before, and their encounters have shaped our planet's story. In the infancy of the Earth, during an era of heavy bombardment, countless meteors and asteroids rained down. Each impact scarred the young world, heating and melting its surface. Yet within that chaos lay opportunity. Many asteroids carried water locked in minerals and carbon-rich compounds. With each collision, they delivered some of that water to the parched Earth, helping to fill its oceans, drop by drop. They also sowed the seeds of life, bringing complex organic molecules that would later spark the earliest life forms in Earth's primordial seas. One colossal collision in Earth's early days stands out among all others. Over 4 billion years ago, a wandering protoplanet, perhaps the size of Mars, slammed into the young Earth with unimaginable force. In that titanic impact, Earth was nearly torn asunder. A vast plume of debris shot into orbit. Over time, the debris coalesced under gravity's embrace to form our moon. In the sky of the still molten Earth, the newborn moon glowed red-hot, much closer than it is today. It must have been a breathtaking sight, hanging huge on the horizon. That catastrophic impact forever changed Earth, granting it a large moon that would stabilize our planet's tilt and slow its rotation. The gentle pull of the moon would later give rise to tides, which many believe were crucial for nurturing early life. Even in violence, the cosmos can set the stage for future tranquility. As eons passed, the rain of impacts eased. Earth cooled, oceans formed, life emerged and flourished. But the quiet was not permanent. Now and then, the universe reminds us of its unpredictability. About 65 million years ago, long after dinosaurs had ruled a peaceful Earth for generations, a new wanderer appeared in the sky. An asteroid roughly 10 kilometers across came hurtling toward Earth. It was likely a fragment from the asteroid belt, knocked off course ages prior. On a fateful day, it pierced the blue sky and struck the Earth, near what is now the Yucatan Peninsula, with an energy beyond comprehension. In an instant, forests thousands of kilometers away were flattened by the blast. The impact gouged a crater over 150 kilometers wide, vaporizing rock and filling the air with searing dust and ash. The flash of that collision ignited wildfires around the globe. In the weeks and months that followed, sunlight dimmed under a veil of soot. The air chilled. The age of the dinosaurs, which had lasted over 160 million years, came to an abrupt, tragic end. Yet, from that darkness came a new dawn. With the great reptiles gone, tiny mammals that had survived in the shadows began to thrive and diversify. Over millions of years, they evolved into countless new forms, including eventually ourselves. In this way, the asteroid that ended one world ushered in another. Destruction and creation are two threads woven tightly in the tapestry of life on Earth. And the silent asteroid, a mere rock adrift in space, was the unlikely harbinger of profound change. Earth bears many scars of past impacts, though wind and rain have softened or erased much evidence. One relatively recent impact occurred about 50,000 years ago, when a meteoroid perhaps 50 meters wide struck the Arizona desert. It exploded with the force of hundreds of atomic bombs, carving out a bowl-shaped crater over a kilometer across. Today, that meteor crater, also known as Barringer crater, remains nearly pristine, a yawning reminder in the landscape of the day a star-born rock shattered the calm of Earth's surface. It is a testament that even smaller asteroids can release tremendous energy. Asteroids continue to make their presence known on smaller scales. In the remote Siberian morning of June 1908, the sky above the Tunguska River lit up with a sudden fire. A small asteroid or comet fragment, perhaps only tens of meters across, entered Earth's atmosphere. Before it could reach the ground, the intense pressure and heat of entry caused it to explode high in the sky. The blast was tremendous, flattening trees in a radial pattern over an area of 2,000 square kilometers and shaking the ground like an earthquake. Though it left no crater, the Tunguska event was a sobering reminder that even a modest cosmic visitor can unleash great force. More recently, in 2013, as the rising sun brightened the winter sky over Chelyabinsk, Russia, an incandescent streak suddenly appeared. A house-sized meteoroid silently entered the atmosphere at incredible speed. For a few brief moments, it outshone the sun as it raced overhead. Then, with a powerful flash, it shattered in the air. The shockwave rattled buildings and shattered windows for miles around. Over 1,000 people were injured by flying glass and debris. Fortunately, none fatally. The Chelyabinsk meteor was another reminder of our planet's ongoing dance with the remnants of creation. Such events prompt us to watch the skies more carefully, in observatories atop mountains and in spacecraft orbiting high above. Scientists keep vigil for asteroids on potential collision paths. These efforts have catalogued thousands of near-Earth objects, mapping their orbits years or centuries into the future. Most will never come near our world. Some will pass by at safe distances, silent travelers we wave to in the night. On rare occasions, astronomers spot an object that could pass uncomfortably close. Each time, humanity stands a bit readier. Plans are being drawn and tested to gently redirect any asteroid that poses a serious threat, perhaps using the gravitational pull of a spacecraft or the force of a precisely timed impactor, nudging the cosmic rock just enough to miss Earth. In 2022, one such test mission successfully changed the orbit of a small asteroid's moon. proving that with preparation, we need not be helpless against these messengers of doom. We are not entirely without cosmic protectors either. The giant planet Jupiter, occupying an orbit far beyond Mars, serves as a gravitational guardian of sorts. Its tremendous mass often deflects or absorbs comets and asteroids that venture inward. In 1994, humanity witnessed a dramatic example when comet shoemaker Levy 9 broke into pieces and plunged into Jupiter's atmosphere, creating Earth-sized fireballs in the Jovian clouds. Jupiter had pulled in a comet that, had it struck Earth instead, would have caused unimaginable devastation. Over the ages, Jupiter's presence has likely reduced the frequency of catastrophic impacts on the inner planets, as its gravity slings many potential threats away, or gobbles them up. At the same time, Jupiter's gravitational tugs can also perturb the asteroid belt and send some fragments our way, so its role is complex, both protector and occasional instigator. Nonetheless, without Jupiter, the inner solar system might have been a far more hostile place for life. Interestingly, the same asteroids that pose challenges also offer promise. Many asteroids are rich in minerals and water ice. Future spacefarers might use these resources, harvesting water for life support and fuel, and extracting metals for construction, to sustain outposts in space. Some even imagine creating spinning habitats on larger asteroids, or using them as stepping stones for journeys to Mars and beyond. In this way, what was once seen only as a danger could become a gateway to the stars as humanity learns to live and thrive off-world. But it is important to remember that asteroids are not merely agents of destruction. They are also bearers of knowledge and wonder. Consider the asteroid Bennu, a carbon-rich relic from the dawn of the solar system. In recent years, a daring robotic probe visited this ancient rock. Gently, it touched the surface of Bennu and collected a sample of its dust and pebbles, then returned them to Earth. Within those grains lie clues to the chemistry that prevailed as the planets were forming. Perhaps they hold amino acids, the building blocks of proteins, or hints of water from a time before Earth had oceans. By studying these bits of asteroid, scientists hope to better understand how life's ingredients found their way to our young planet. We also find that some asteroids blur the line between rock and world. Ceres, the largest object in the asteroid belt, spans nearly 950 kilometers across, dwarfing all its neighbors. Though small compared to the Moon or planets, Ceres is massive enough that its gravity pulls it into a round shape. It is a little world unto itself, carrying mysteries deep inside. Recent observations revealed bright, salty patches on Ceres's dark surface, likely remnants of brine that welled up from a subsurface reservoir and froze in brilliant white patches. This suggests that even within the asteroid belt, there may be pockets of water and warmth, echoing processes we see on larger planets and moons. Another large asteroid, Vesta, bears the scar of a titanic impact at its south pole. The collision excavated a huge crater and left a towering central peak over 20 kilometers high, one of the tallest mountains known in the solar system. These little worlds may be barren, but they are far from uninteresting. In the grand emptiness of space, the asteroid belt might sound crowded. Yet, unlike the packed images of science fiction, these rocks are separated by vast distances. A spacecraft sailing through the belt would more likely find a deep, tranquil void, with asteroids mere distant glints of light. We have sent several probes through this region safely, proving the belt is no impassable barrier. but rather a sprawling wilderness of solitary, tumbling stones. As we drift mentally through that silent sea of asteroids, we can appreciate their dual nature. On one hand, they are benign relics, cosmic museum pieces preserving the past. On the other, they occasionally awaken history with dramatic visits to the inner worlds. Asteroids have helped shape Earth's environment, its life, and its destiny in profound ways. They remind us that even small objects can have enormous effects in the cosmos. Each day, Earth itself is sprinkled with cosmic dust as it plows through the debris of asteroids and comets. Dozens of tons of tiny particles rain down harmlessly through the atmosphere. And on any clear night, when a shooting star streaks across the sky, it is a gentle reminder of our planet's connection to these wanderers of space. For now, we bid farewell to these drifting stones, humbled by their power and their gifts. They remain silently afloat, as they have for eons, witnessing the turning of ages. With a sense of respect and wonder, we leave the asteroid belt behind and venture farther out. Saturn, with its magnificent rings, floats before us like a dream made real. Its pale golden atmosphere is banded with subtle stripes, and a gentle haze softens its features. For centuries, gazers through telescopes saw Saturn as a picture of celestial calm, an almost perfectly round world adorned with concentric circles. But beneath that tranquil facade, Saturn's atmosphere is anything but calm. Here, in this giant realm of gas and cloud, lurk storms of a scale and intensity that challenge the imagination. Approaching the planet, we first encounter its crown jewel, the rings. Though they appear solid from afar, up close they dissolve into countless icy fragments, each orbiting in its own path. The rings cast delicate shadows on Saturn's cloud tops, striping the planet with thin, dark bands. In the stillness of space, the rings silently glide, a timeless ballet of ice and dust. Meanwhile, below them, Saturn's atmosphere churns and roars. Saturn is a gas giant, lacking a true solid surface beneath its clouds. Its atmosphere gradually thickens into fluid layers as one goes deeper, transitioning into exotic forms of matter under crushing pressure. The planet spins rapidly. One day on Saturn lasts only about 10.5 hours. This swift rotation flattens Saturn slightly at the poles and drives strong jet streams in its atmosphere. These jets, ribbons of wind, race around the planet, separating its cloud bands. At the equator, Saturn's winds reach astonishing speeds, over 1,000 miles per hour, far faster than any hurricane on Earth. In these roaring currents, immense storms are born. One of Saturn's most captivating mysteries lies at its north pole. Here, encircling the pole is a colossal hurricane-like structure, but with a perplexing twist. Instead of a round swirl, Saturn's north polar storm is shaped as a hexagon. 6 giant sides, almost equal in length, form a geometric pattern in the clouds, centered around a rotating vortex. This hexagonal jet stream is enormous, about 30,000 kilometers across, spanning more than 2 Earths side by side. It's a long-lived feature, observed since the Voyager spacecraft flew by in the early 1980s, and still present during the Cassini mission in the 2000s. Within this hexagon, winds howl at around 300 miles per hour, making sharp 60-degree turns at each corner with uncanny precision. How could nature produce such a perfect, six-sided shape in something as chaotic as an atmosphere? Scientists believe it's a standing wave of wind, a product of Saturn's rotation and layered airflows that somehow settled into a stable, oscillating pattern. It remains a mesmerizing enigma. As we imagine it now, high above Saturn's cloud tops, we see a twilight world at the pole, with a huge rose-colored hurricane eye at the center of the hexagon, captured in infrared images, and endless dusk circling around in a six-sided race. It's a silent, otherworldly storm, turning ceaselessly in Saturn's sky, decade after decade. Saturn's secrets don't end with the North Pole. At the South Pole of Saturn, another immense vortex churns, a planetary hurricane with a well-defined eye, discovered by Cassini. This southern polar storm has an eye wall like a terrestrial hurricane, but it is fixed in place over the pole and is about 5,000 miles across, dwarfing any earthly storm. Saturn, though quieter in appearance than its neighbour Jupiter, periodically unleashes tempests that rival the largest storms in the solar system. About once every Saturnian year, roughly 30 Earth years, a brilliant eruption of cloud appears somewhere in Saturn's atmosphere. Astronomers call these events great white spots. They appear as bright, white, stormy towers of cloud that can be seen even through backyard telescopes when they erupt. One was first noted by observers in 1876, and several have been recorded since. The Great White Spot is not just a spot at all, but the birth of a colossal storm system. The most recent one to grace Saturn began in December 2010, in the planet's northern hemisphere. Initially it was just a small, shining blotch in Saturn's cloud bands, but it grew with astonishing speed. Within weeks, this storm had spread and wrapped itself around the entire planet, forming a girdle of turbulent white clouds encircling a latitude in Saturn's northern half. It was as if Saturn had been cinched by a belt of storm. Cassini, which was orbiting Saturn at the time, watched as this monster raged. Lightning within it produced crackles of radio noise detectable across space. The storm's clouds billowed high, dragging up material from deeper layers. In the aftermath, Cassini found that the storm had dramatically altered the atmosphere. It left behind a region of higher temperature and unusual substances, like ethylene gas in its wake, signs of violent mixing. The Great White Spot storm slowly dissipated over the next year, but its effects lingered. For years, a disturbance remained visible where the storm had been, evidence of the atmosphere's memory of that great convulsion. Apart from these rare planet-spanning tempests, Saturn hosts more frequent storms as well. There are storm alley regions, particularly around the planet's mid-latitudes, where storms come and go regularly. Some of these storms manifest as giant, oval-shaped systems, comparable to smaller versions of Jupiter's Great Red Spot, though none last as long as Jupiter's centuries-old vortex. Through the eyes of Cassini, scientists saw flashes of lightning on Saturn, something no human had seen before. In the darkness of Saturn's night side, Cassini's cameras caught faint flickers inside deep clouds, illuminated by the sun's glint off the rings. These were massive lightning bolts, some estimated to be thousands of times more powerful than typical lightning on Earth. Imagine the scene within those clouds. Towers of ammonia and water vapor clouds rising, charged particles rubbing together to spark immense electrical discharges. A sudden flash lights up the swirling darkness for a brief moment, revealing turbulent cloudscapes. Then all is black again until the next burst. Cassini also listened to Saturn's lightning storms using its radio instruments, hearing eerie whines and clicks as radio waves from the lightning propagated through space, a cosmic thunder echo. What fuels such tremendous weather on Saturn? Part of the answer lies deep within the planet. Saturn, like its fellow gas giants, generates heat in its interior. In fact, Saturn emits more energy than it receives from the distant Sun. This excess heat likely comes from helium, slowly separating from hydrogen and sinking towards the core, a kind of helium rain, releasing gravitational energy as heat. That internal warmth bubbles up, providing energy to drive convection, the same process that causes thunderstorms on Earth, but on a gigantic scale. Saturn's fast rotation helps stretch these convective storms into bands and eddies that can merge into planet-wide disturbances. The Sun, though much weaker at Saturn's distance, still plays a role by heating the upper atmosphere and driving seasonal changes. Saturn's axis is tilted, so it has seasons, each lasting over 7 Earth years. During summer or winter in one hemisphere, sunlight, though faint, or the lack of it, can shift wind patterns and perhaps help spark new storms. The Great White Spot of 2010, for example, emerged just as the Northern Hemisphere was warming into spring after years of winter darkness, hinting that the change of season was a trigger. Despite the violence of Saturn's storms, there is an eerie silence to them from our distant vantage. If one were in the midst of it, the sound of wind and thunder would be overwhelming. But from space, we see only the graceful ballet of clouds. One can watch a time-lapse of a Saturnian storm as a white plume unfurls and wraps around the planet, all in total silence. It reminds us how different conditions are on a world with no solid ground and dim sunshine. Through it all, Saturn's rings serenely persist above the fray, seemingly untouched by the mayhem beneath. Those rings, made of trillions of ice particles from pebble size to boulder size, lie in Saturn's equatorial plane, where the pull of gravity and the balance of orbital motion keeps them spread out in a flat disk. The storms of Saturn, confined to the atmosphere below, do not directly disturb the rings. Yet the planet's changing winds and temperatures can subtly affect ring shadows, and perhaps even the thin atmosphere that some ring particles carry. There is a sublime juxtaposition in Saturn's realm. Below, the churning atmosphere with its fleeting tempests. Above, the cosmic stillness of the rings, where nothing but gentle collisions and sunlight occur. Over time, even the rings slowly change. A fine mist of ice particles from the rings drifts down into Saturn's upper atmosphere. A ring rain that very gradually diminishes the rings. In perhaps 100 million years, Saturn's iconic rings may become thinner or even vanish, proving that they too are transient. In a way, Saturn embodies the dual nature of cosmic phenomena, ferocious energy bounded by delicate structure, chaos and calm intertwined. Saturn's many moons also add to its story of wonder. The largest, Titan, possesses a thick golden atmosphere denser than Earth's. Titan is a frigid world, yet it has a weather cycle akin to our own in some ways. But instead of water, it is methane that rains from Titan's sky. Titan's clouds drizzle methane onto its icy surface, filling lakes and rivers with liquid methane and ethane in the polar regions. In 2005, the Huygens probe parachuted through Titan's orange haze and revealed a damp, cold landscape of hills and drainage channels leading to dark hydrocarbon shores. It is an alien yet eerily familiar scene, a moon with rain, lakes, and perhaps occasional methane thunderstorms, all under a perpetual orange twilight. Meanwhile, another moon, Enceladus, gleams with fresh ice and shoots geysers of water vapor and ice grains into space, snowing material into one of Saturn's rings and hinting at a liquid ocean beneath its frozen crust. Saturn is not only a planet of storms, but the master of a dynamic system where even its moons have weather and contribute to the planet's environment. As we take in the sight of Saturn's tumult and beauty, we recall that this giant planet, for all its grandeur, is but one child of the Sun. Saturn's storms, impressive as they are local events on a far-flung world. Yet the Sun itself, the common source of light for Saturn and for Earth, also brews storms. Storms that can span the breadth of the solar system. Indeed, even as Saturn experiences its own tempests, it is immersed in the constant stream of particles and magnetism from the Sun, a reminder that all planets are connected to that central star. We leave Saturn with one last glance at its rings, catching the sunlight and its pale globe beneath. The memory of Saturn's stillness and its storms will remain with us as we continue. Our journey now turns toward a new focus. Far from the giant planets, we now turn our attention to the space through which they all travel, the realm dominated by the Sun's influence. Though the void between worlds seems empty and silent, it is filled with an invisible motion, a constant stream of particles and magnetic fields emanating from our star. The Sun is not a quiet ball of light. It is a dynamic, active star that breathes energy into the solar system. This ever-present flow of charged particles and occasional violent outbursts from the Sun is what we call space weather. Every moment, the Sun emits the solar wind, a diffuse gust of electrically charged particles, mainly protons and electrons, that blows outward in all directions. The solar wind is born in the Sun's outer atmosphere, the corona, where million-degree heat gives some particles enough speed to escape the Sun's gravity. As this wind streams past Earth and the other planets, it carries with it the Sun's magnetic field, stretching and twisting it into a vast, spiraling bubble that envelops the solar system. In a sense, we live within the Sun's extended atmosphere, nestled inside this invisible heliospheric wind. Most days, the solar wind is steady and gentle, causing little disturbance. Earth's own magnetic field holds it at bay, carving out a protective bubble called the magnetosphere around our planet. Like a stone diverting the flow of a stream, Earth's magnetosphere forces the solar wind to flow around us, usually keeping our atmosphere safe from being eroded away. This magnetic cocoon shields us by diverting most charged particles. In the process, some of those particles become trapped in two vast rings around Earth, known as the Van Allen radiation belts. Invisible bands of energetic particles encircling the globe. Within these belts, electrons and protons spiral along magnetic field lines between the polar regions. They pose a hazard to satellites or astronauts who linger too long in their path. But down on Earth's surface, we remain protected beneath this magnetic umbrella. But the Sun has its tempests too. At times, dark magnetic regions on the Sun's surface, called sunspots, grow and crackle with energy, spawning explosions of light and matter. These explosions are solar flares, bursts of X-rays and other radiation. and they often coincide with coronal mass ejections, or CMEs, which hurl billions of tons of hot plasma into space. When one of these eruptions is aimed toward Earth, the serene space around us can suddenly become stormy. Imagine the journey of such a solar storm. A bright flare erupts on the sun's face, and just minutes later, a surge of X-rays and ultraviolet radiation reaches Earth, traveling at light speed. This sudden blast ionizes the upper atmosphere, disrupting radio communications and sometimes causing brief blackouts of GPS and other signals. Meanwhile, a cloud of charged particles from the CME is racing outward behind that initial flash, slower than light, but still incredibly fast, perhaps a few million kilometers per hour. It might take a day or two for this wave of solar plasma to reach Earth's orbit. When it arrives, it slams into Earth's magnetic shield, compressing it. The onslaught of particles and magnetic energy tangles Earth's magnetic field lines and pumps energy into our magnetosphere. This is the onset of a geomagnetic storm. Down on Earth's surface, we are safe from the direct effects of these solar particles, thanks to our thick atmosphere and magnetic field. But our technologies, and our electrified way of life, can feel the sun's wrath. Strong geomagnetic storms induce electrical currents in long conductors like power lines and pipelines. There have been instances when solar storms knocked out power grids. In March 1989, a severe solar storm collapsed the electricity network in Quebec, Canada, within seconds, plunging millions into darkness on a cold night. Transformers blew out in an instant as unseen currents coursed through the ground. The auroras that reached far south that night were beautiful, but they came with a cost. It was a stark reminder that even 93 million miles away, events on the sun can have immediate consequences for us on Earth. Communication satellites, orbiting outside much of Earth's protective layers, can be damaged or temporarily knocked offline by the bombardment of energetic particles. High-frequency radio used by airplanes and ships can fade or crackle with interference during solar flares. Astronauts, especially those beyond the safety of low Earth orbit, must be cautious. A powerful solar flare could expose them to dangerous radiation. During the Apollo era, for instance, an enormous solar storm erupted in August 1972. Luckily, it occurred between moon missions, but had astronauts been en route or exploring the lunar surface at that moment, they might have suffered serious radiation illness. This is why space agencies keep close watch on the sun, ready to alert astronauts on the International Space Station to take cover in shielded areas if needed, or to postpone spacewalks until the danger passes. The most notorious solar storm on record occurred in September 1859, long before our modern electrical civilization. But even then, its impact was noted. Known as the Carrington event, after the astronomer who observed the flare, this storm was so intense that it lit up skies around the world with auroras. People in tropical latitudes like Cuba and Hawaii were astonished to see the night aglow with rippling curtains of green and red light. The telegraph systems of the time, the cutting-edge technology of that era, sparked and malfunctioned. Some telegraph offices caught fire, and operators received electric shocks. A few telegraph lines mysteriously operated without batteries, powered by the storm's induced current. If a geomagnetic storm of that magnitude struck Earth today, it could severely disrupt our technological infrastructure. Scientists estimate that in July 2012, a solar eruption on par with the Carrington event missed Earth's orbit by a narrow margin. Had it hit, we might have experienced widespread power outages and satellite failures. Yet there is a flip side to these solar tempests, a side of exquisite beauty. When the charged particles from the sun stream down along Earth's magnetic field lines, they collide with atoms of oxygen and nitrogen high in our atmosphere. causing those atoms to glow like tiny neon signs. The result is the aurora, the northern and southern lights. These luminous draperies of colour grace the polar skies during geomagnetic storms. To witness an aurora is to see space weather painted across the heavens. Under a dark sky near Earth's poles, one might gaze upward and notice a faint greenish band on the horizon intensify, rising and undulating like a living thing. It might ripple overhead, curtains of eerie green unfolding with edges tinged red or purple, shimmering as if blown by an invisible breeze. Sometimes the lights form towering rays or a corona directly above, where filaments of light seem to rain down. All of this happens in silence. There is no sound to the aurora's dance, just the hush of the cold night and the cosmic light display. To an observer, it can feel like being inside a giant, dimly lit celestial cathedral, the sky alive with silent fire. These auroras are the beautiful face of space weather, a natural wonder that has inspired awe and legends for millennia. Inuit elders spoke of spirits playing ball in the sky. Scandinavian lore imagined gods riding across the heavens. Even when we understand the physics behind the aurora, the sense of magic remains when you see it shimmer and sway. Earth is not the only world that experiences space weather. The solar wind and solar storms extend their reach to every planet. During big solar outbursts, Mars, lacking a strong global magnetic field, can have portions of its upper atmosphere stripped away, as spacecraft have observed. The Moon, with no atmosphere, simply endures the particle bombardment on its sunlit side, while the night side builds up an electric charge that can sometimes make lunar dust levitate. Jupiter and Saturn, with their powerful magnetic fields, have their own spectacular auroras at their poles, far larger than Earth's and glowing primarily in ultraviolet light. Jupiter's auroras are a permanent feature, fed not only by the solar wind, but also by volcanoes on its moon Io that spew ions into Jupiter's magnetosphere. Even Voyager 2, as it journeyed toward interstellar space, detected shockwaves from solar flares still potent billions of kilometers out. Our Sun's presence is truly felt across the solar system. In fact, the heliosphere, the vast bubble blown by the solar wind, acts as a shield against some of the galaxy's cosmic rays. High-energy particles from distant supernovas are partially deflected by this bubble. When the Sun is active and its wind is strong, fewer of these cosmic intruders penetrate into our cosmic neighborhood. During the Sun's quiet lulls, a few more slip through. Thus, the Sun not only gives life, but also provides a measure of protection from the broader universe, buffering our little planetary oasis from the harshness of interstellar space. Thankfully, we are growing more adept at predicting and preparing for the Sun's outbursts. A fleet of observatories constantly watches the Sun, including satellites stationed 1 million miles sunward from Earth, to give advance warning of incoming solar storms. When they detect a strong CME headed our way, power grid operators and satellite controllers can take precautions, putting spacecraft in safe mode, adjusting satellite orbits, or temporarily reducing power grid loads to mitigate potential damage. In essence, as we come to understand the Sun's moods, we learn to live in harmony with the rhythms of our star. While space weather can pose hazards, it also reminds us that we are deeply connected to the Sun. The very existence of auroras tells us that Earth is linked to the Sun by invisible threads of energy. In a way, the Sun reaches out and touches our world, not only with the gentle sunlight that sustains life, but occasionally with a more urgent, forceful touch that reminds us of its power. Yet those touches also produce beauty, like the auroras, illustrating that even disruptive forces can have a graceful side. The Sun's outbursts gradually calm, and the ethereal auroras fade back into the polar sky. We have felt our star's invisible breath and seen its dancing lights. Now we turn to the source of it all, the sun itself, the brilliant heart of our cosmic neighborhood. We approach now the center of our solar system, the mighty sun itself. It blazes ahead, an immense glowing sphere of plasma, pouring light and warmth into the surrounding darkness. Even from millions of kilometers away, its brilliance is overwhelming. The sun is the heart of our cosmic family, and its power defies ordinary understanding. By its light, day exists. By its warmth, life thrives on a small blue world. Yet for all its familiarity, the sun holds deep mysteries and unfathomable strength. Our sun is a medium-sized star, one of hundreds of billions in our galaxy. But to us, it is unique and irreplaceable. It contains 99.8% of all the mass in the solar system, dwarfing every planet, moon, and asteroid combined. Over 1 million Earths could fit inside its volume. In its core, the sun fuses hydrogen atoms into helium, producing a colossal output of energy. Every second, about 600 million tons of hydrogen are converted into helium. In that process, around 4 million tons of matter are transformed into pure energy, according to Einstein's famous equation, E equals mc2. This energy slowly radiates outward through the sun's interior layers, taking a long, random walk, sometimes tens of thousands of years, to reach the surface. Once it finally escapes as sunlight, it takes only about 8 minutes to travel across 150 million kilometers to Earth. Consider the sheer magnitude of the sun's power. In a single second, the sun releases more energy than humanity has consumed in all of human history. Its output is equivalent to billions of 1 megaton nuclear bombs detonating each second. And yet, nestled here on Earth, we receive just the tiniest fraction of that energy, enough to warm our days, drive our weather patterns, and fuel the growth of plants. The sunlight that falls upon a leaf, triggering photosynthesis, ultimately powers the vast tapestries of forests and fields. The sun's rays, reflecting off the moon, softly illuminate our night as gentle moonlight. The evaporation of water to form clouds, the stirring of winds and ocean currents, even the cycles of climate, all are orchestrated by the sun's energy. The sun is a constant, reassuring presence. Each dawn, it rises, or rather, we rotate into its light, bringing colour and life to the world. Each dusk, it paints the sky in hues of gold, pink, and purple before giving way to night. Since time immemorial, living creatures have set their rhythms by this steady pulse of light and dark. If we could somehow hover just above the sun's visible surface, an impossible feat with current technology, of course, we would witness a seething, boiling vista. The surface of the sun, called the photosphere, is about 5,500 degrees. It's not solid ground at all, but a roiling sea of hot gas. Granules the size of continents continually form and dissolve as hotter plasma from within wells up, cools, and sinks again, rather like the bubbling surface of a pot of thick soup, but on a tremendous scale. Occasionally, darker patches appear on the sun's face, sunspots. These are regions slightly cooler than their surroundings, perhaps 4,000 degrees instead of 5,500 degrees, marked by intense magnetic fields that suppress the bubbling convection. Sunspots can grow larger than the Earth and often come in clusters. Over days or weeks they emerge, shift, and fade as the sun's magnetic field tangles and relaxes. The number of sunspots waxes and wanes in a regular rhythm known as the solar cycle, which lasts about 11 years. During solar maximum, when sunspots abound, the sun is more restless, with frequent flares and CMEs. During solar minimum, the sun's face can become nearly blank and quiet for days at a time. The solar surface is mesmerizing and a bit intimidating. Tongues of flame, prominences, often leap up from the edge, limb, of the sun, guided by magnetic loops, sometimes towering 100,000 kilometers into space before raining back down. And above all of this lies the ethereal corona, the sun's outer atmosphere, which can only be seen from Earth during a total solar eclipse or with special instruments. The corona shines with a pearly white light and has a wispy, crown-like structure shaped by magnetic fields. Curiously, it is extraordinarily hot, millions of degrees, far hotter than the sun's surface below, a paradox that solar scientists still strive to understand. In a total eclipse, when the moon momentarily blots out the photosphere's glare, human eyes can behold this ghostly halo stretching far into space, an apparition of the sun's extended power. For a brief few minutes, day turns to twilight, the air grows still and cool, and the sun's surrounding aura becomes visible in all its glory. Then, as the moon moves aside, a brilliant bead of sunlight flashes at the edge, the diamond ring effect, and daylight returns once more. Such celestial events have captivated humanity for millennia, as the great light in the sky is briefly obscured and then reborn, revealing the hidden beauty of the corona before our star's full shine resumes. It is a reminder that even our steady sun has its moments of dramatic revelation, and that there is always more to discover just beyond the light we normally see. From the sun's surface, if we could look outward, we would see its domain extending unimaginably far. Its gravity holds the planets in their orbits, from scorched Mercury, only 58 million kilometers away, to distant Neptune, circling at 30 times Earth's distance. The planets dance around the sun in nearly the same plane, obeying the gentle tug of the sun's gravity, which perpetually pulls them inward, while their sideways motion keeps them perpetually falling around the sun, rather than into it. It is a beautiful balance. In our mind's eye, we can picture the solar system from above, the sun as a brilliant lamp at the center, and the planets as tiny motes caught in its gravitational thrall, moving in stately clockwork paths. This stable configuration has persisted for billions of years and will continue for billions more. The sun's influence likely reaches even farther, out to the Oort cloud, a distant spherical shell of icy bodies, perhaps a light year away. Those trillions of comets are bound so loosely to the sun that passing stars or the tidal forces of the galaxy occasionally perturb them, sending some wandering inward as long-period comets. Yet even at that immense distance, almost a quarter of the way to the nearest other star, the sun's gravity still holds a grasp on its small companions. It's astonishing to realize that the sun's gravitational embrace spans a significant fraction of the distance to the next star. Not only is the sun the gravitational anchor of our system, it is also the source of light and heat that defines our home. Earth orbits at just the right distance, the habitable zone, where temperatures allow liquid water to persist on the surface. A bit closer to the sun, like Venus, and our oceans would boil away. A bit farther, like Mars, and much of our water would freeze. We live in a fortunate, temperate sweet spot, and we owe our existence to this star's steady output. It's as if Goldilocks found a bowl of porridge that was just right. Earth found a star that is just the right warmth. From ancient times, Humans sensed the sun's importance and often worshipped it as a deity. Ra, Helios, Surya, Amaterasu, recognizing that its light was life. Today, while we understand it in scientific terms, the awe remains. When you stand in a sunbeam and feel its gentle warmth on your face, you are feeling the touch of a star across 150 million kilometers of space. That warmth is carried by photons that left the sun's surface mere minutes ago, and by infrared waves that softly heat your skin. It is a connection intimate and profound. We are literally bathed in starlight every day of our lives. In addition to sustaining life, the sun has also shaped the very matter that makes up our world and ourselves. The iron in our blood, the calcium in our bones, the oxygen we breathe. None of these elements were made in the sun, which mainly fuses hydrogen into helium. They were forged long ago in earlier generations of stars and in titanic supernova explosions that seeded the galaxy with heavy elements. Our sun formed about 4.6 billion years ago from one such enriched cloud of gas and dust, inheriting that stardust. In time, planets coalesced around it, incorporating those ingredients. Thus, Earth and all life on it are truly children of the stars. We are made of atoms assembled in stellar furnaces, now illuminated by a star that continues the cosmic cycle. It's humbling and wonderful to realize that the sun, while providing daily warmth and light, also connects us to the wider universe and deep time. Though the sun feels eternal from our perspective, it too has a life cycle. Having burned for roughly 4.6 billion years, the sun is middle-aged. It shines steadily now, but it will not always be so hospitable. In about 5 billion years, after using up the hydrogen fuel in its core, the sun will begin to change. It will swell into a red giant, a luminous giant star much larger than its current size. In that swollen state, its reddish surface will likely expand to engulf Mercury and Venus, and perhaps even Earth. If Earth somehow survives inside the sun's expanded atmosphere, it would be scorched and sterilized. Long before that happens, however, the gradually increasing brightness of the sun, it brightens by roughly 10% every billion years, will have made Earth's surface too hot for liquid water, maybe 1 billion or 2 billion years from now, effectively ending life as we know it. But such timescales are so vast that they almost lose meaning to us. They are millions of times longer than the span of human civilization, longer even than the existence of complex life on Earth. For now, and for many eons to come, the sun will continue to be a stable, life-giving star. It's often comforting to know that the sun will rise again each day, shining with nearly the same energy, a reliable anchor in our ever-changing world. When the sun eventually exhausts its fuel, it will cast off its outer layers into space, creating a beautiful planetary nebula, a glowing shell of gas expanding outward, perhaps forming intricate patterns. The core of the sun will remain as a white dwarf, a hot, dense ember about the size of Earth, slowly cooling over trillions of years. By then, the sun will no longer illuminate the solar system as it once did. The remaining planets, if any, will circle in cold darkness around the faint white dwarf. But the sun's cast-off layers, enriched with elements like carbon and nitrogen from its late-life fusion processes, will disperse into the interstellar medium. Someday, far in the future, that material might become part of new nebulae, new stars, and new planets. In that way, The sun's death will sow the seeds for new beginnings elsewhere, just as our sun was once seeded by stars before it. All of this will occur on timescales that stagger the mind. It reminds us that even stars are born, live, and die, as part of the grand cycle of creation and destruction that governs the cosmos. Here and now, we can be grateful that we live in the sun's warm and vital presence during its long period of stability. The sky we know, blue by day, star-filled by night, is a gift of this particular era in the solar system's story. Having reflected on the sun's might and generosity, we prepare to venture beyond. We turn our gaze outward, toward the fringes of the sun's kingdom, and into the vast sea of stars beyond. Leaving the sun far behind, we venture now into the outermost reaches of its influence. Out here, the light from our star grows faint. By the time we pass the orbit of Pluto, the sun is no longer a blinding beacon, but just an extremely bright, star-like point in the darkness. In this distant realm lies the Kuiper Belt, a broad ring of primordial icy objects left from the solar system's formation. Pluto itself is one of these. Alongside it are other dwarf planets, such as Eris, Makemake, and Haumea, and countless smaller ice rocks. These frozen worlds orbit in the dim outer twilight, with surfaces of methane and water ice, and occasionally thin atmospheres that come and go. They represent a bridge between the planetary zone and the true interstellar frontier, circling the sun in these remote borderlands. Beyond them, the warmth and light of the sun wane even further. The warmth we know on Earth has dissipated to nearly nothing. A deep chill pervades the void. We have entered a realm of cosmic twilight, the threshold between our solar system and the wider galaxy. As we travel further, we encounter the boundary of the sun's domain. The solar wind that streams outward from the sun every day eventually meets the faint winds of other stars, the sparse, hot gas that fills the space between star systems. At this boundary, called the heliopause, the sun's particle winds peter out, pressed back by the thin pressure of the interstellar medium. It is here that humanity's farthest messengers, Voyager 1 and Voyager 2, have journeyed. Voyager 1, launched in 1977, crossed into interstellar space in 2012 at roughly 18 billion kilometers from the Sun, about 120 times farther than Earth's distance. Voyager 2 followed in 2018. These hardy spacecraft reported a sudden drop in solar particles and a rise in cosmic rays from the galaxy, telling us they had left the protective bubble of the heliosphere. Beyond lies the interstellar ocean, more emptiness, sprinkled with the faint traces of distant stars. Even so far out, the sun still holds on to some members of its family. Circling the sun at distances thousands of times greater than Pluto's orbit is the Oort cloud, a vast, spherical swarm of icy bodies. These cometary nuclei, countless in number, drift in cold storage, orbiting so slowly that a single loop might take millions of years. They mark the farthest frontier of the solar system. Here, the sun is just one star among many, and its gravitational grip is tenuous. Occasionally, a passing star or the tidal forces of the Milky Way will jostle an Oort cloud comet, nudging it onto a new path. Some of those nudged bodies begin a long fall toward the inner solar system, gradually accelerating under the pull of the sun. As they draw nearer, the sun's warmth begins to vaporize their ices, forming glowing comas and long, misty tails that can stretch for millions of kilometers. These are the long-period comets, cosmic visitors that may appear unexpectedly in our skies, shining for a brief time with a trailing veil of dust and gas before retreating again to the outer dark. Perhaps the ancestors of these comets witnessed the birth of our sun. Perhaps their descendants will see its death. One famous visitor, Halley's Comet, loops around the sun roughly every 76 years. It spends most of its time out in the frigid darkness beyond Neptune, then sweeps into the inner solar system, sprouting a radiant tail visible from Earth. In 1986, it was visited by spacecraft that flew by its nucleus, finding a dark, potato-shaped object venting jets of gas, a dirty snowball coming to life under the sun's warmth. Comets like Halley's remind us that even at the solar system's edge, there are still links that connect back to the heart of our system. Continuing outward, the last traces of our sun's family fade away. If we turn around now to look back toward our sun, what would we see? To the naked eye, not much. The planets would be far too faint and lost in the sun's glare to pick out. But if we had a magical perspective or a powerful telescope, we might see the sun as a brilliant star at the center, and tiny pinpricks of light circling it, the final glimmers of Neptune and Pluto. Closer in, perhaps the slight gleam of Jupiter or Saturn could be discerned, if one knew exactly where to look. Earth, from this distance, would be almost indistinguishable, a mere speck of bluish-grey dust caught in a sunbeam. It was from a vantage point beyond Neptune that Voyager 1 turned its camera back toward Earth in 1990 to take the famed pale blue dot photograph. In that image, our planet appeared as a single pale dot, less than a pixel in size, suspended in a beam of sunlight within the vast darkness of space. Everything we are, everything we have ever known, was contained in that tiny point of light. This humbling perspective is a profound truth. From the edge of our solar system, one realizes how small our home truly is against the backdrop of the galaxy. And yet, floating in that darkness, we also realize how special our solar system is to us. It is our cradle in the cosmos, the only home we have ever known. The 8 major planets, the myriad moons, the belts of asteroids and comets, and our guiding sun. Together they form a cosmic family, each member moving in its own rhythm, yet all bound by gravity and history to one another. We have journeyed through this family of worlds in our imagination. We skimmed the surfaces of ancient asteroids. We braved the storms of giant planets. We felt the touch of the sun's winds, and we basked in the glow of the sun's brilliance. Now, at the edge of the solar system, we prepare to take leave of our familiar neighborhood. In the distance ahead, beyond the influence of our sun, lies the vast expanse of the Milky Way galaxy. The nearest star, Proxima Centauri, is over 4 light-years away, more than 1,000 times farther than the edge of the Oort cloud. It would take Voyager tens of thousands of years to approach that distance, and Voyager isn't aimed toward that star anyway. The gulf between stars is almost unfathomable, filled with sparse gas, dust, and the faint light of far-off suns. But it is also a space that beckons future explorers. One day, perhaps, spacecraft or even intrepid humans may cross that abyss intentionally, carrying with them the legacy of our solar system's wonders. For now, though, we linger a moment at this frontier. In the silence, we might imagine we can still hear a faint cosmic chorus, the whisper of the solar wind fading behind us, the distant farewells of our Voyager probes, and the timeless quiet of the stars beyond. We have seen how the sun's light nurtures life on a small planet, how the planets each hold their own marvels, from rings to great storms to methane seas, and how even the emptiness of space is filled with the sun's influence. Our journey through the solar system has been vast and serene. It's astonishing to think that all the phenomena we've witnessed, the meteor showers, the eclipses, the auroras, the sunrise seen from another world, originate from this one star system we call home. And though the universe is immense beyond measure, with countless stars and worlds, the solar system will always hold a special meaning to us, for it is ours. Now, as we bid farewell to our sun's realm, we carry with us a sense of peace and wonder. The countless stars begin to surround us on all sides, no longer outshone by the sun's glare. They twinkle gently, inviting us to dream further. But we can rest here, at the edge of all we know, and reflect on the voyage. In the quiet of this moment, imagine floating in interstellar space, looking back at the faint glow of our sun. Somewhere in that gentle luminosity, all the familiar planets are circling, each one a comfort to us now because we have visited them in our minds. The solar system feels like a tiny, delicate jewel in the vastness, and indeed it is. The cosmos beyond is deep and mysterious, but it does not feel as cold or forbidding as it once did, for we carry with us the warmth of our sun and the memories of the worlds we've explored. The same starry background that once made us feel small now feels like a protective blanket, filled with stories and possibilities. We are part of this universe, made of the same stardust, moving to the same cosmic rhythms. As our journey comes to an end, let us slowly drift into a restful silence. Above us, the stars continue their slow dance. Behind us, the sun quietly shines on, its family of planets in tow. And within us, there is a calm knowing that we too are part of this beautiful cosmic story. Now let your breathing slow, in and out, like the gentle tides of the cosmic ocean. Feel any tension melt away as you float in this expanse of serenity. Above you, the stars keep their quiet watch. Below you, the earth turns calmly. You are safe, cradled by forces that have shaped worlds and will carry you through the night. At this moment, there's nothing you need to do and nowhere you need to be. You are simply here, enveloped in darkness, soft as velvet, and starlight old as time. Let go of any lingering thoughts. Let them fade like distant galaxies. You are weightless, drifting on a slow cosmic breeze, your mind as clear as the space between planets. The wonders of our solar system whisper a lullaby in your memory. Planets, rings, comets, all is at peace. The quiet hum of the universe surrounds you, a gentle chorus that lulls you deeper and deeper into rest. Feel how your heartbeat aligns with the calm rhythm of the cosmos, steady and unhurried. As you close your eyes, imagine a tiny spark of starshine glowing within you, warm and tranquil. With each soft breath, that glow grows, filling you with comfort and ease. You are part of this endless universe, a child of the stars, and in this knowledge there is profound peace. Sleep now, in the comforting embrace of the cosmos. Let the silence of the infinite night soothe every part of you. You are part of something grand and beautiful, now and always. Rest and drift into a deep, dream-filled sleep under the gentle watch of the Milky Way. Good night.